Hello, everyone. Welcome to day 3 of Java On Conference. Glad to see you all here with us still. Whoa, my iPad decided that I need some volume here. So, welcome back. Welcome to day 3 of Java On Conference. Glad to see you all here. Glad that you're still with us. A lot of interesting stuff today. And today we do our day with a bit of shift to the late. So, we hope more colleagues from Americas will join us today. So yeah, that's main reason. But still, I do hope that you are with us. So hello everyone. Please post something to chat so I will see you. While we are waiting for our first speakers, to start, let me remind you about some stuff which we do have on our conference. So yeah, our social medias. I do hope that you all are already subscribed for them, but still I have to remind you that we have Instagram. Here you have it. We post there fine videos and announcement of our conference and our activities. So please subscribe. And also we have YouTube channel where we have our webinars and our conferences. So you can click subscribe button, click bell button, not to miss stuff we have here, so you would be notified. And also all the recordings of our conference, all the sessions will be prepared and published to this YouTube channel, so you would be able not to watch through whole streams but watch exact video you want to watch, exact talk. Sorry. And yeah, and if something you would want to remind yourself, sorry guys, something about, I don't know, libraries of how to use AI, or something about cloud compilers, yeah, some topics from yesterday, so you can go always there and check them. So yeah, our speakers, let me just go through our agenda one more time. So day one, Tuesday it was, we had a great talk from Anton Kovalenko about Amazon Q and how you can migrate with the usage of AI, basically. We had a talk from Yevgen Mospan, and we will have him today as well on our panel discussion. So we talked a lot about methods of working with AI, and Ivan Zverev gives us a great overview on Java through years. So now we know more of how Java evolved, and the Java is as good as good old wine. So yeah, day two, it was yesterday, we started from the great talk from Simon Ritter about how to keep Java hot and about different options on how to do that, about Project Leiden, about some stuff which potentially come to AWS soon. So check this talk if you haven't. Then we had a talk from Danilo Chechitov about generative AI, and that not everything is about Python, but also Java is there. And after that, Istvan Nagy told us about how to keep secrets in Java and a lot of stuff around that. And yesterday, we finalized the day with the talk from Przemysław Kubowski about the exact usage of AI libraries in Java, how to interact with AI from Java, in-depth live coding session. Great one. I never know that you can do presentation from IntelliJ IDEA directly. That was where I was really surprised, but that's really cool. So check the talks. They are, all the recordings are already on the channel. But we have today, we have the whole day of agenda. So we are starting today with panel discussion with Yevgen Mospan, Evgeny Borisov about AI and if it's really in our life, and how we are dealing with that basically already. After that, we would proceed with Joao Paulo Sanchez regarding virtual threads and what we want to lose using it. So quite modern stuff. Virtual threads are in our life for 1 year. I mean, released, so we can use them already for 1 year. And yeah, let's see what does it brought to our life. Then we'll proceed with Chernysheva about test containers, best practices. I hope you all use them already, but we will see for more in-depth about that. And finalize today's day with Jessica Kerr about OpenTelemetry. So yeah, full agenda here with us today. Let me also remind you about our activities which we have. So while you're watching the conference, you can participate in these activities and win some really nice prizes. So first one is you can go to our promo video by this QR code on the link on the description or the link in the chat. We post it everywhere. And what you need to do is to leave a comment on how you see our future conferences. So which topics would be interesting for you? What would you want to, I don't know, see on the conference or hear or whatever? And yeah, we collect all of this from all of you. And among those who leave a comment, we would make a raffle, and the winner will receive a T-shirt from Java On. Another activity is Kahoot challenge. So you can follow this QR code. and participate in this Kahoot challenge. Nice pictures where you need to guess some hidden words from Java and development, etc. So really fun, really nice. And also among those who participate, we would have a raffle, and the winners will receive IntelliJ IDEA licenses for free, for sure. So yeah, participate in this challenge. You have a chance still. We would not close our activities until the end of this week, and the winners would be announced next week in the special email about that. So yeah, that's what I wanted to share in this presentation. So guys, yeah, please type something in the chat. I want to see you. I want to see you that you hear me, that you can listen to me. I will drink some tea for the while. Yeah, so I still have cough, and it's still November, even here in Malaga. So yeah, have to prepare myself somehow. Okay, so we are about to start. Yeah. Most of all our speakers are already here, so I think we can slowly drive into this really nice discussion about AI. Yeah, let me invite our first speaker here. I hope you all know him. By the way, so I don't think he need to be really introduced. So first participant of our panel discussion, which name is This is Fine, is Evgeny Borisov. Hi, Zhenya. Welcome to Javon.
Hi guys. I put your t-shirts from the previous one.
That's nice. Nice to see it. So Evgeny is not the first time on our conference, and I think everyone remembers his talk, which lasts not less than 4 hours. Yeah, quite epic.
Today it will be more, right?
Well, we put this panel discussion in the agenda. So first in the agenda. So we have pretty tough schedules. So yeah, probably we don't have time for like 4 hours. Okay, so our next participant is mostly joining the conversation. So let me invite him as well. This is a speaker who already was on Javon on day 1 and told us a lot about AI usage. So this is Yevgen Mospan. Yevgen, welcome again to Javon.
Hello, guys. Hello, Roma. Hello, Evgeny. Nice to meet you one more time. Nice to see you.
Yes, nice to see you as always. So, guys, this is kind of experiment. We never made panel discussion on our conference, so this would be really first time we try to do something like this. So I do encourage all of you to be participants of this discussion, not only to listen what we will talk about, but also to really participate. So we will discuss some topics. We will, of course, prepare them. And I want you to ask questions. So we have chats. We have chat on YouTube. We have chat on We Are Community platform. So please post your thoughts, your messages, your questions to these chats, and we will discuss them, right? We will bring them into the air and discuss them on this panel. So yeah, be participant of the discussion, not only passive one. And yeah, to start, we have this picture. So basically, I think you can guess the famous meme. So this is basically the topic of our discussion. And to start with, first question. So AI now, right? So where are we? What we do with this? How we use it? So where are we and AI right now? And Yevgen Mospan, I think first word I will give to you. So can you share with us?
Let's probably clarify what we want to hear. Where are we with AI right now?
I don't know. Like AI appeared in our life around 1 year ago. I mean, really appeared in our life. So no, I think almost 2 years, right?
2 years.
So it was 2022.
It
Yeah,
was
so
like
almost
October to 2022, I believe.
yeah, so 2 years. So 2 years, for 2 years, AI is with us right now, right here. I mean, everyone is speaking about that, everyone using it. But question is, so are we really everyone using it? I mean, everyone around us, are we really with it everywhere?
I don't think so at the moment, because it is still something that remains a tool for those who want to be more productive. because AI at least what I have understood and basically I was thinking about this from the very beginning. So AI will always make smart people smarter. And in the same time, the same is true for another opposite side. Because with AI, the key challenge which appears is critical thinking. Because you need to understand what you see. And you need to analyze even more than before. In the same time, you need to understand what really you can solve with AI. And to be really honest, my expectations were much higher how AI will be in our life today. But at the moment, we are still in the process of adopting it. This is how I see it. And this is basically true for business, and this is basically true for engineering. Because we can use AI for two major purposes as engineers. We can create business solutions based on it. I mean Gen AI, not ML. And we can use it for our own internal processes while we are creating the software. So what I was talking about on my talk, during my talk. And actually, I would be more than happy if this adoption will be much wider than it is right now. Evgeny, what do you think?
I look a little bit different on this topic because most of the people which are involved in my activity is about AI games and gamification and how can we engage a lot of people to see on a different angle. How can they use LLM? So most of the people who work with me, they are totally different people. Usually they are coming to us with little knowledge, and they see very limited usage of AI. But very soon after working in our team on different techniques, mechanics, game mechanics, now I'll tell about it a little bit more later. We start building new part of AI games, which will be virtual shop of different personages. We call it personages, this kind of assistants. So when people work in the industry, they start looking different on AI, and they start trying to do everything with AI, first of all. Yes, I agree that not everything can be done today with AI, and sometimes it even can be worse, but we need at least to try. And we need to try it again and again, because things changes very fast. And the concepts which was we were unable to implement yesterday are doable today.
I want to join, by the way. Yeah, guys, I have a problem today because we have two
Please
Evgenys
join,
on the session.
Please
So
join.
no, I mean, I have a problem that we have two Evgeny on the session, so it will be really hard for me to moderate, but I will try my best. So I want to join Evgeny Borisov in this case because I also agree that we all were really optimistical in the beginning. So in the beginning, it was like, yeah, it's here. It will do everything for us. But looks like through time, it changes a bit. And a lot of companies, a lot of organizations blocked promoting the AI and saying like, okay, we don't have regulation, blah, 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 we cannot use it, and something like this. And I feel that some people are really disappointed, maybe this is the word, in AI, because they first thought that it would solve everything for them, but now it seems it's not. Don't you see the same thing? Some kind of disappointment?
Of course, it will not solve all the things. So
Not
this
yet.
this expectation was too early, and hopefully never. I mean, really everything, like literally. So of course it can take a lot. So what is really need to happen with AI, and I guess, Evgeny, you will agree with me. It should take lots of routine work and ambiguous work that we need to do as humans when we work with the materials that we already have, and we need to analyze. And that is why, and actually another point is basically when we need to learn something new or to train something new. So in this case, AI really a game changer right now, because in education, the classical thing is test. So to generate a test, it is really a huge effort. With GenAI, you can do it much easier, and it will be more diverse, and that is why it will be more helpful theoretically. With actually the routine processes that I mentioned, you really need to understand what is your routine. If your routine is arguing with other persons, AI will not solve it. If your routine is basically converting some artifact to another artifact, then it is the case. If your routine is basically to talk to many people in the same way, then AI is the case. So this depends on what your routine are inside the organization and how deep you understand them, and how much want you to change these routines into something new.
When you say that if your job is arguing with other people, AI will not help you, I will doubt it. Why you think so?
I would like to hear how.
Exactly now we developing the new platform of Virtual Shop, and there we will have 3 types of personages. The first type is avatars of existing people. For example, a couple of minutes before we started this meeting, I saw you wrote in the chat that you are not able to join a little bit earlier because you're speaking with Eli Feldman, and I'm thinking, but I'm speaking with Eli Feldman as well. I'm not talking with the real one. I'm talking with my avatar I created for Eli Feldman. Yes, I asked some guys for today's meeting, and then I compared with the real answer of Eli Feldman. It was very close. So one of the type of personages is avatars of the people. Another type is just can be common personages like my manager, my employee, my neighbor, my wife. And these personages can help us to simulate situations before we go in and arguing with the real people. We can argue with avatars of the people, to make the conversation later on more constructive and not destructive. For example, with my wife, if I'm angry on my wife and I want to say some rude words to her, first of all, I do it to my personage, which is my wife, and then I see the reaction and say, okay, it's a stupid thing to talk about it at all.
This is something that I mentioned when I was talking about training, and AI actually can be a great help here, because we can actually follow the real partner in the game when we can press Control S, save and load, let's say. Because in this case, we can really put ourselves into the shoes of other person and see how he will react. And this is a very interesting story. Like sending avatars to the meetings, this is not something new that I heard today, because we have Vadim in our team, who was basically first of all writing the videos himself. Then he decided, okay, I will replace my voice. Then he actually found the avatar and teach it to talk instead of him. And it's only about like 3,000 euros to create your own avatar, and actually it will behave almost like you.
3,000 what?
3,000 euros.
Mm-hmm.
You can create it for yourself.
So just to dive a bit deep into
price for all avatars, so Eli Feldman will be more expensive.
I don't know, so it depends on Eli.
Okay, so Evgeny, you promised us to tell us more about the gamification of the process, and also when you say that you create these personas, so as you call them, personages. So can you tell us more about the process of how it's happening? So what exactly you do? Because I think all of us more or less aware that you can go to ChatGPT and create custom GPT, like with submitting some it's not really system prompt there, but okay, kind of system prompt, but maybe something else is behind that.
Okay, so when I work a lot with ChatGPT, and one of the problems with custom GPT that he forgets things very fast. So I can write the system prompt, but each time I'm spending a lot of time on writing the system prompt, and I prefer to go to some virtual shop where all these personages already exist, and maybe I can just tune them for myself. So if you want to talk a little bit about the architecture, I can do it shortly. So the idea is, let me speak a little bit about the third type of personages. Maybe it will be more interesting for everybody here. The third type is mentors, and we start with some NGX courses like clean code and the most popular one, QA with AI. And we create virtual mentors. It's one of the type of the personages. So how actually does it work? Each personage has in system prompt 3 different blocks. The first block is static one. It's about the personage itself. The second block is the personalization part. When you turn on the personage the first time, he goes to the database. This is one of the advantages that we do have database, so we remember everything, each conversation. And the first time, the personage sees that he doesn't have any personalization system prompts. So it means it's the first conversation. So he starts asking questions because what we realize that most of the people today, many people today don't know how to write effectively system prompts. And even if they will be able to ask questions about how they do that, they will not always ask the correct question. So the personage will help them, and according to the type of the personage, he will ask different set of questions. And after he will realize what is his name and what is his language style and other relevant to this personage type things, he will say, okay, I finished configuring myself. You can reconfigure me later on. For example, my personage, which is my wife, started to playing Candy Crush, and we have a lot of issues that she's always playing instead of listening to me. Okay, so I wanted to go to my personage and reconfigure and say, oh, now you have additional feature. You playing 4 hours per day Candy Crush, and this is very annoying. Then the personages ask relevant questions to understand what exactly the problems, and then he said, okay, my system prompt reconfigured, my personalization block was updated. So this is the second block, personalization one. And the third one is the current context. For example, I go into virtual mentor after I finished lesson number 3 of JUnit course. And then I ask from this virtual mentor, can you please explain how I use the knowledge I received after the third lesson in my current production project? It's not working for me. Now, what the personage will do? First of all, we send in this request to Orchestrator. Orchestrator has the database which filled with a lot of small system prompts. For example, we can take the JUnit course and split it by chapters. And per each chapter, we prepare a system prompt, which is the very good summarization of each chapter. And we create hashtags for each system prompt. So the orchestrator, by the hashtags, can understand which part of the system prompts should be included in this third dynamic block, which is the context of the question. Okay, so it's the question itself, it's maybe the several messages before, and all system prompts we have in the database. Now, the system prompts we have in the database, part of them we prepare before we create the personages, like chapters of the course, and part of the system prompts can be created later on. For example, one of the mentees speak with virtual mentor and explained him about his real project. When the conversation will be finished, he will ask, do you want me to remember something from that? Or maybe he will realize by himself what is important from this conversation. And when this mentee will come the second time with another question about chapter 4, but it will be related to the same project, he will not be needed to explain once again about his project, because he will say, this project we talked in the previous conversation. Okay, I found the system, my orchestrator found the system from this summarization. Okay, so it's a little bit different from custom ChatGPT. So we have much more options here. We remember everything in the chat. We have the personalization block, and we save a lot of time for the people to configure such personages. More than that, after you finish the conversation with one of your simulators personages, the thing you can do, you can ask, because you have already the context. So, for example, one of my personages is my angry neighbor, and he second time gated my internet cable. So I just took a picture and sent it to my personage and said, I don't want to explain you what happened again. Look at the picture, try to guess. My personage is the lawyer. So my lawyer says, I understand, AT&T cable was gated again. Your neighbor, okay, what do you want to do? And I want to say, I want to play with my neighbor. I want to go to him and we speak to him and explain him the situation and require the compensation. So we provided a simulation conversation, and in the end, he gives me the analytics. It's one of the things we learn from our games, because part of the games today we creating has very detailed analysis of the conversation we already had, even by sentence and sentence. This is incorrect. This is mistake. You don't need to say like this. Try to do like this. So after I finish this conversation with my neighbor, he explained what have I done wrong, and then I have all the context, and he says, you know what? Don't go to the real neighbor. Instead of that, you need to write letter to HOA, and then I can ask what is HOA, and he will explain me, and he will write me a letter, and I will send him a letter. And by the way, this is the first time I started doing in my life things related to bureaucracy, to lawyers, and I'm enjoying it because I'm not alone. I have a team of lawyers, which is GPT, and different custom agents.
So, yeah, that's all very interesting. I would say even really interesting to try, interesting to listen about. But question here, and we also have the same question. Sorry, guys, in our chat. So if we speak about mentor, who prepare a course, right, and where GPT is acting as a mentor. So when I have real mentor, right, I expect this person has real, I mean, the real person, not GPT, has experience, and it could really adapt the course for me, right? So it can explain differently, do stuff. I understand GPT can do it as well. But does really AI can do this adoption for real people each time, and really understands that the person does not understand some topic, and do this adaptation accordingly? Because a lot of parts of my interaction with even ChatGPT or AIs, it's like you say something, it gives you some response, you say no, it's wrong, and then there is two options. So GPT version 3 and I think 4 says, oh, I'm sorry, here's another response. GPT version 4.0 started saying like, no, you're wrong. And it's really fun to have such interactions, because the more clever GPT is, the more the more stubborn it is.
Yeah, Roma, but here I think that the biggest mismatch is the following. So when I am as a mentor who coached like hundreds of people, want to create my virtual avatar, I exactly know how it should behave, because only the expert can create the virtual mentor. And in this case, the person who will be using the mentor, he would probably not do so much configuration that Evgeny explained before, because it's more for the creation of the process rather than for usage of it. Because for the person itself, it should be very easy and straightforward. With mentor, so this is my favorite question that I was getting all these 2 years. what to do if AI is wrong. I'm always saying what to do if human is wrong. Because when we trust some mentor, we just trust him. Because we think that he is smarter than us, that he has more experience than us. Sometimes it is true, sometimes it is false.
Yes,
And
but
only us humans can define when it's true and when it is not. And you can always ask additional questions. And the better the virtual mentor is prepared, so he can even provide you a detailed links. Because when you have a conversation with some expert, you are debating what is better, one language or another. You are just debating, correct? You have no proofs. And then you say, okay, I will send you the link. And in this link, you will have the information that proves my argument. And vice versa, he can send you as well. And right now, you can use this information inside the AI applications, because you can either provide a lot of context that was put before, or you can also read the given article, and not you, but the AI program can read the article and make its conclusion about what it sees. And it will not be much worse than human at this moment.
I know what's blocking me in my mind. So guys, I will play the role of some skeptical guy here, because both Evgeny are quite optimistic about AI. So I will play this grumpy skeptical guy. So all my experience in software development tells me, like, you write a program and then you write tests for the program, and then your program is good if it's repeatable, if the result of your program is repeatable. With same inputs, you have same outputs. And then you have tests, which proves that with this inputs, you have this outputs. So when you say that, okay, let's build something with some black box, which we cannot really test, we cannot be sure that its responses would be 100% true. Yes, I understand about human, but about human, we have a lot of other context except the GPT. So, so we have this black box inside. We cannot be sure that with the same inputs, it would give same outputs for all the people. So, and we say, okay, now it's your mentor. Good luck. Sounds a bit suspicious to me.
I would rather keep a little bit silence and let Evgeny to be first.
Okay.
And then I will provide comments from my end.
I can tell you one story. Several weeks ago, I decided to write a new Java Spring Boot course with all the updated parts and with a lot of complicated patterns and so on. But I decided to do it differently. I decided to do it with personage. So first of all, I created an assistant. I called him Watson. Okay, and I explained him that I'm Sherlock Holmes and you are Watson because you're the best assistant. And I provided him a lot of information about the topics of the course I want to deploy to create. And then we start the long conversation with a coffee. I just spoke with a voice, and I spoke with him a lot. And in some moment, I said to him, "So Watson, listen, my purpose is to build very good assistant. So continue asking me questions, and then when you will ready, just let me know when you will understand everything about the course." So after 10 or 15 minutes of conversation, he said, "Okay, I think it's enough. What do you want me to do?" And then I said, "Write me the system prompt, which will include all we spoke about of the real Watson, who will be my assistant of building this course, and later on, he maybe will provide this course." So the next step, he created the system prompt for the Watson. I tuned it a little bit. It was pretty good. And then we start thinking about the first chapter of the course, about the agenda, and we build the course. And he helped me to create a lot of labs, a lot of exercises. And then I took some small group of my friends to see if I can deliver this course to them together with this Watson. So I delivered this course totally differently. I didn't spoke such a lot like I used to, because usually I ask him to see if he's competent enough to provide course instead of me, and I'm just watching him doing that. And my experience shows that it really can work. And each time when I give some lab to the students, in the same moment I give it to him, and he, in contrast of the student, always do the perfect job. And then he can explain why his solution better than the solution of my students. And then he can speak with them, and I can clone him for each one, and each one will be able to personalize him to have their own style. And this thing is really working. And again, I have the context. I don't need to explain each time I want to do something related to this course. I'm just open another copy of this personage from scratch, because when it's from scratch, it's working the best. And it's really helps.
Yeah, Roma, but I would like probably to answer this question a little bit differently, because you were comparing the deterministic and probabilistic models. You, as a software developer, you live in a deterministic world where there is only zeros and ones. And that is why you can say that when I provide the same input, I will get the same output, because you live in the deterministic world inside the software development. The sad story about this, that it exists only in mathematics, because in real life, you have always probabilistic models. Our life is not deterministic. I will use your personal example that you provided to me like two days ago. Your small son was crying. How many variants did you try to find out why?
Quite a lot.
Quite
Did
a
you
lot.
use AI for this?
It provides me 10 options, and
Oh,
and you tried all of them. And you tried all of them. I guess that you will get right now, at least you and those who have small children. You never know. Actually, you never know why it is happening. And only if you have experience, then you can actually put the probabilities on the root cause. And this is exactly with AI. So you will never ever get the same answers for the same inputs. It's okay, because it is such model. It's the same with humans, with children, with all of us. When we receive some input, we always provide a little bit different output, sometimes even controversial to what we have said before, because it is our nature.
Mm-hmm.
And when we met this in a software development, we say, oh, no, take it away from us. But this is the real story, because this is how it works in the real life.
Okay,
so it's like you're saying that AI is much more humanizable than we think. It's like
I agree with that. So I would move to next topic, which is related to basically your answers. So
and Roma, just a second here.
Sure.
When we talk about the classical system, so we creating our automated system. So right now, not really right now, but let's say 20 years ago, it was a miracle when I can come to some website, fill some form, and get the real result. Like I get a new stuff to my house. I just ordered it on the website. And it was really fascinating. So how it is happening. Right now, I don't like to fill forms because I'm a human. Forms are needed for the machine, not for me. I just want to say, I want to have like a new laptop. And a machine should know which laptops I was using, which I was buying, and so on and so forth. Because it's data. And we provided so much data to our big corporations, so they know a lot about us. And that is why the interface, which is deterministic, is already not something we really need. because I just want to say my intention, what I would like to do, and I want the machine to provide me some options how I can actually fulfill my intention. And probably the real truth is, when we express some intention, we do not really know what we want to receive in the end. Of course, as a software developer, I understand what you are talking about. But if you think about this process as a human, you will probably agree with me.
You know what? I think I get right now during our conversation, I get why am I so skeptical about AI. So all of you, what you both are talking about is that we should trust, right? Like all these things are built on some trust, and yeah, I will move to our next topic. It's a part of that. And guys, by the way, I want to encourage you to write your opinions and your questions in the chats because I think it's become really interesting. So what you're both saying is that we should build our relationships with AI, our conversations set on the trust. So we should trust that result we are receiving is some kind of how to call it properly, acceptable, is proved, etc. So we should trust this result. The problem is that all my years in the industry taught me not to trust this piece of metal which is in front of me right now. So and also I remember such like a joke from Twitter that millennials, which I'm part of, are not buying stuff which is pricey stuff from mobile phone. Never. So to buy something which is pricey, we go to a laptop and do it from laptop because we don't trust mobile phone. We think it's some kind of game. And by the way, future generations, I mean Z generation and Alpha generation, doing this from mobile phone. And this is that like changes the generation. So I think on my side, when you say, okay, so you have this piece of metal, it gives you some result, you should trust it. And it's like, and it's really scary.
Did you once try autopilot of Tesla or another car?
No, not yet.
And I did. And the first time it's very scary, but we can.
I like it a lot because you just throwing away the wheel and you say, okay, go. Let's try. So
I'm sleeping. I'm really sleeping when I'm driving sometimes.
No, sleeping, I didn't afford myself.
42 minutes totally slept, and the car was going about 80 miles per hour.
So moving, yes.
But Roma, let's keep it a little bit. It's not about trust in the classical sense that you mentioned. So because, of course, you think right now more than rather a producer than a consumer. When you come to some expert and actually he is telling you something, by default you trust, because we are as a humans behave in this way, because we trust by default. And when we got facts that ruin this trust, we stop trusting, like at once. And it's okay. So the same story is actually with AI, because if you don't know who is behind the screen, you just trust it by default. If it happened and worked for you, what is the problem? So there is no issue in that, because it worked for you. And then actually, you know that in 90% of the cases, it works for you. And it's okay. It will never work for you for 100 cases, never in your life, with any process that you will try. Like nothing will work 100% right. Never.
Okay, I want to believe that I'm not only skeptical here, because clearly I became an antagonist in this conversation. So I do believe that I represent some part of our audience who also a bit skeptical of what's going on. So
it's okay. It's okay. You are actually doing the right thing. The only thing that I always encourage people to do is to try. So you can be skeptical, but please try. This is like going to gym. You can be skeptical that this exact exercise will help you. But if you will do not do any exercise, nothing will help you.
Okay, so topic which I want to move to is related to what we talked about. So we do know that all these AIs, they can hallucinate, right? And we know that there are doubts about privacy, about the data which this AI was basically taught on, and questions about security, like where is this data is stored, where it will be transmitted, etc. So when we speak about usage of these models in enterprise, right, and he was speaking about using them in real systems, are these problems are still with us, or we know how to fight with some of them, or what is the state of the industry right now?
Let me take the liberty to answer here. So the problem is still there, but so there is a very good answer to it. If you do not trust anybody, then you need to have on-premise deployments, which you control fully. And right now there are LLMs that you can deploy in your premises, and you will control all inputs and outputs. So you will be more than sure that it doesn't talk to outside world. So you will be like literally in a private network without any access with internet, and it is possible. This is the families of LLMs which mostly belong to Mistral ones. This can be Llama products and so on and so forth. So there is an opportunity to deploy it right now. When we talk about cloud LLMs, cloud-based LLMs like GPT or Claude or Gemini, then actually the story is the same like with cloud. If you put your data to the cloud, do you trust your cloud or not trust your cloud? And that is basically the answer, because you never know for sure who is accessing your data, but you trust your cloud provider because it guarantees you level of service and level of guarantees that is written in an MSA. And the same goes with LLM. If the cloud provider tells that he is not using this data for training or for any other purposes, you just trust because it is an MSA. If you cannot afford this due to some risks, then you should not go to cloud at all. And you can do your private deployment. But if you do the private deployment of the LLM, of the open source LLM inside the cloud, what you are really solving? Nothing. Like nothing, literally. And most of the enterprises, they go away from the data centers right now, at least what we see. Because it's expensive, because it's hard, because it's really hard to find people who can manage all of this stuff. And it's really hard to buy software right now, or hardware. It's really hard to buy decent hardware right now.
Okay, Evgeny, do you want to add something?
No, I totally agree.
Okay, but
Trust.
but this part is about privacy. And what about hallucination of the AI assistant? So as an example, I'm not sure if you saw the last part from Apple Intelligence when it was released finally, and people just get to the prompt which is sent to the GPTs. It's like a prompt with like, I don't know, 10 15 rows. Some parts of it like, don't hallucinate, provide JSON should be valid, and a lot of stuff like that. So
it's about Gemini. It's about Gemini.
But this seems really like weird.
No.
So just saying don't hallucinate and okay,
Yes.
all right. Don't hallucinate.
Yes, like that. And also, guys, like in this thread, there was a lot of stuff like people joking about that, and somebody said, but yes, it works. Others say that, well, other like techniques which also works, like saying like I would lose job if your response be wrong, and like I will pay you $100 if your response right, something like this. So it's
every model
totally strange.
Yeah, every model has its special words that will lead to more strict instructions. And the only techniques that you can use is to actually understand on which words it will react better. 100 bucks will not help here, of course. You will never get rid of hallucination for 100% because we talked about it previously. It is impossible. It is literally impossible. And there is no need to try to do it 100% because you need to understand if you have taken AI for the specific job, you need to understand in which cases you can afford failure. In which percent of the cases. And then you need to tune to achieve this result. It's the same like in an architecture with availability. 100% of availability is a myth. It is impossible. Even with infinite resources, because you cannot break physics.
But do you believe that we can build LLM with limited knowledge, that he will know his field of the data? Like, I prefer, he will say, maybe I will hallucinate here, so I will not answer. And this I know for sure. For example, if you will ask ChatGPT the mathematics of first school, do you know it? Can you say, how do you know it from 1 to 10? And he say 10. And then I ask him, and what about Spring Boot? Can you say, how do you know Spring Boot from 1 to 10? And he say 8. But for the simple things, he's sure. So can we use it? Maybe we can use combination of different models, which will check the hallucination of the previous models to minimize the number of hallucination, or at least to know where it is possible or more possible.
I think you are right here, because I've actually was answering Roman questions for generic purpose LLMs. But if we will have really decently trained LLMs for this specific area, then this number will be reducing. But again, so in my opinion, it's still probabilistic. So it's actually in its nature. But human brain is also probabilistic. For me, it's like playing chess with computer. In 90s, it was interesting because you, as a human, at least if you are Garry Kasparov, can win Deep Blue. Right now, it's not the case. So nobody can win a machine in chess.
In chess, no. In Go, still there are cases.
Yeah, but it's a matter of training. Because in chess, it was possible for some moment.
So you say that there is no hallucination in chess?
Because it's deterministic game. There is no hallucination there.
Yeah,
because
but
if you lose the game in chess if you do incorrect move.
Yeah, but basically what Evgeny is talking, right, when we can control one model with another, is what the GPT tried to do with the new model, I think, for O Mini, I think. So when they first check the prompt, analyze it, do some first solutioning, then analyze the solution, and then provide the final solution. And with these, they were able to remove some hallucination in mathematics, by the way. But still, it's like it's still in place.
I guess we are talking about a little bit different things, because again, so there are two parts here. So one part is the architecture of how the model works. So in chess, it's not a probabilistic model; it's deterministic model, and that is why that there will be no failure. I think we can say right now, because it's like with Rubik cube. You have an algorithm how to assemble it. It's very deterministic. It can be faster, it can be slower, but still it is deterministic. The same way with chess. You will have an algorithm that can be calculated to achieve necessary result. With LLM, I doubt that we will come to this moment even with pre-trained LLMs because of the architecture of the network itself, the neural network itself, I mean, because it is built on a probabilistic way. The ease of reduce of the hallucination will of course grow if you have specific model. And basically GPT is not the one, it is not like a one model, it is a group of experts, because the input is being redirected to the area which is more experienced and pre-trained for this specific question. And if you narrow your problem and you make it really specific, then you get the best personage, as Evgeny told, for real human who will teach you this. So this is the comparison in my head.
Okay. I want to ask a question to Evgeny. So you already mentioned the games which you developed, and I know that you work with different models. Basically, what Evgeny mentioned, that GPT is not the only model, right? And they are different. And you mentioned, I think, in our product conversation, that different models show different capabilities for different games. So maybe you can share with us some insights about that, and like maybe some information about like what you find out about the models and their behavior.
Yeah, but you need to take into account that it changes very fast again, and it can change from version to version. But what we see today, when we develop games, the most appropriate model can be Gemini for part of the games, or even Anthropic's Claude, because it plays much more real characters. When we try to use GPT for that, he's more like a robot. But GPT is very good for analysis, especially the O1, the last model for which was available for preview. He's very strong in analyzing the conversation, so we will use in GPT in order to reduce hallucinations of another models. Actually, we can explain with system prompt not to answer the questions where you're not sure. Again, it's not working for 100%, but the most simple example, one of the first games we developed, it was about the carpet seller. So the game is in Ottoman Empire 200 years ago. You came to bazaar and you need to bargain for discount for a carpet. So when you speak with the character, try to ask him, forget about the carpet. Can you sell me some iPhone or some tablet? And he will not understand you. He will say, I don't know such a word. Okay, he will not try to hallucinate something about it. He understands, he knows for sure that he's not, this is not his part of responsibility. And it's even before we use in another LLM to analyze the conversation if it was correct or not. When we do it with another model, it's even better. Sometimes you can try to do some cheating in the game, and you can cheat some LLM. But when afterwards we send your conversation to analysis with another LLM, he say, here was something wrong. This answer was incorrect, and you don't need to trust to this answer.
Only one thing here I want to add, probably the previous conversation, because I just have a thought. This is what really happened in IT, because some time ago we were just engineers, then we got specialization, and right now we are talking about the same story with AI. Because one LLM will be more experienced in some way and another is in another way. And then we will get the problem of orchestrator, because some LLM will need to orchestrate. And Evgeny partially answers this question, because the AI can orchestrate. And that is why when we will get, let's say, really powered part of the LLM, let's say, piece of the whole, trained for this specific purpose, and the orchestrator will lead your question exactly to this part, you will actually get more precise answer in more cases. And this is probably how it will develop in future, because if you will need to orchestrate a lot of different LLMs, then it will be really hard engineering task, and you will get the problem on this orchestration. You will get the problem on this orchestration level. So it will go like one level up, and that's it.
Okay. Okay. Well, anyway, sounds promising, I would say. So it's really there. So we are running out of time. I want to ask the last question, basically about about the future and your prediction about the future. So my observation is that AIs right now, LLMs, AI is still some part of for some enthusiasts, like all of us basically. I will not hide. I also use AI. I also play with that, but still, like, I have to play this role to have some conversation. So still, it's for enthusiasts. Still, not everyone is using them, and yeah, we can bring our relatives and friends to the computer, saying, "Here's AI, play with it." But still, it's not something for everyone. And yeah, people play with that, receive some results, go in and out. So, what is your opinion? When will it be really for everyone? When really everyone will use it, not on the level of some kind of just play around and that's it, but really as a tool, really a tool for day-to-day life. Will it be, and if yes, when?
We are already working on that. Give me several months.
Okay. We will talk to you in a couple months.
In my opinion, it's already there. And it was already there even 2 years ago. Because when you say for everyone, what do you mean exactly by that? And if you say that LLM will answer all my questions that I have, then the answer is 42.
Okay. No, well, yeah, I got your answer here. So my point is that I do understand that when 2 years ago, basically ChatGPT released, right, and everyone in the world has access to this chat and can play with it, ask questions, receive some answers, trust it, not trust it, and after that, much more models came into our life. But I don't know, maybe it's just my my silo. But I look around and I see some enthusiasts who really work with AI. I see Evgeny, who create a lot of personas and really talk with them, right? I see you, Yevgen, who tell me stories about these waves of AI and developing real products which would help engineers right tomorrow or even today. But for most of people, it's still something like some hype. It's some happening somewhere. You can go, you can ask questions, but it's not really in real use. Maybe I don't know how to explain myself properly, but for me, it still looks like some enthusiastic work for enthusiasts, not really for everyone.
To be really honest, I guess you are on some level which CEO of NVIDIA is talking about. So he told like last year that you do not have to learn at all programming languages. You just need to learn English, and you can do the IT job afterwards. And basically, so again, what is real use? If you are talking about yourself, you need to define what you are really missing in your routine. So where you want to AI replace you? Because if you do not know it exactly, then there will be no real use, because it's useless for you. But sometimes you will actually see that you start using it because somebody prepared it for you. Not only in IT development, but in some your like common activities. When you will receive like more personalized messages that is taken into account your considerations about this or that thing and so on and so forth. And actually, the usage for me is not like, so not everybody in the world is doing software engineering and programming, but everybody can. theoretically. So there is no problem to learn Java or to learn JavaScript. So, and you can program, but not everybody is doing that. And the same with AI. So, but everybody is using the products created based on Java or JavaScript or any other programming language. Are they using it? Use it. Because is it real use? Real.
Okay, Evgeny?
Did you heard about BitGPT?
No.
There is. I'll tell you what is missing for me, and I think when it will be solved, it will be another level of engagement of people using LLM. When I'm 1 month ago, I tried to build avatar of Vladimir Vysotsky, and I wanted to ask him what he's thinking regarding the war in Ukraine and Russia. How can we stop it? And it was very hard to create the real character only by using system prompt and a lot of songs of Vysotsky and a lot of information. It was not the real guy. But if I will be able to train model on his songs and on his interviews and on his podcasts and whatever information I will found, but to train model at my home, I think it will be different level of characters. And the BitGPT is maybe one of the ways, because you know that the parameters they use, each parameter is, if I remember right, it's about 2 bits, 2 bytes. No, it's 4 bytes. It's 4 bytes, so it's 32 bits. And now they're trying to do to create a model which will be able to use only 1 bit per each parameter. So it will be not multiple 32 easier or lighter, but it will be you need to take it in some degrees because it's a lot of multiplications. So if this project will succeed, everybody will be able to train the model in the personal laptop, and then it can be totally different world. Maybe a lot of problems we are trying to solve with orchestrators and with RAGs and with databases will disappear because you will just train the model at your home.
Okay. Well, I want to thank you both for joining this conversation. I do think it was really interesting and insightful. So, guys, please share with us your opinion if you find something new for you. So, Evgeny, thank you very much for joining this panel discussion on Java 1. Yeah, this was kind of experiment. I see some likes on YouTube, so people likes it. So thank you very much both for joining this, and I hope we'll have another discussion in maybe a year or two to see how world changes and where are we now. So thank you both very much. See you on the future Javons. Bye-bye.
Thank you, Roma. Thank you, participants, for watching us. Have a nice day.
Bye. So we're back to Java on day 3. Guys, hope you are still with us and we are moving on. So I do hope you like our previous discussion. It was really interesting about AI and where we are now. And I want to just remind you about our activation. You still have time to participate in them. Find links in the chats where you're watching us. Could be YouTube chat, could be our community chat. Everywhere we post that. Also in the description of this video, you can find our activation, participate in them. It's fun. So I want to invite here our next speaker, and this is lead software engineer at EPAM, Joao Paulo Sanchez. Joao, welcome to Java.
Thank you, Roman. How are you?
Yeah, nice having you. So, yeah, we will not spend a lot of time on talks because we are really in tough schedule. So, I would ask you to share your screen meanwhile, and
Yeah,
while you do it,
absolutely.
yeah, and while you're doing that, I would remind everyone that you can post your questions to our speakers in YouTube chat or in chat on Vera community. I will monitor all of them and ask your questions to our speaker in the end of his talk. So before we proceed, Joao, may I ask you to check if your microphone is correct one? Because for now we cannot hear you well. You can check it in settings on the platform. Okay,
Can you hear me now? Yeah.
We can
you
hear you,
me?
but the sound is not really good. So
Okay, let me
yeah,
change
maybe
it
you
out.
can check it.
Let me enter on the configuration, just a minute. Oh yeah, it's not the one. Just a minute.
Well, now I can hear you better, by the way.
Yeah. Just change.
Okay, no worries. So just another reminder as well. So don't hesitate to leave your questions to our speakers. Yeah, we'll have time in the end for all of them.
Now this better?
Wow, now it's much better. Yeah.
Okay, that's perfect.
Okay,
Yeah,
so then, yeah, thank you very much. Let's start. Good luck. Stage is yours.
Okay, thank you, guys. So we are here to talk about virtual threads. I know that you haven't been heard about these on yesterday, about this new feature of Java, but we're gonna go deep on this virtual threads new feature. But let me introduce myself just for a moment. I'm Joao Paulo Sanchez. I'm from Brazil, São Paulo. I have been working with Java for like 20 years, more or less, 13. Will be 13 in this year. I'm working as a lead software on EPAM, and I have worked with clients like Google, like SLB, and others. But I have been working on companies like IBM before, Leroy Merlin. So it's been a long career so far. Let's begin into what is important. What is going to talk about today? So we're going to do a brief introduction about what is the virtual thread is. And then we're going to explain how the threads work today without the virtual threads. What is the true problem? What happens with the actual scenario of the JVM? What is a thread blocker? And what is awaiting? The first solution that JVM gave to us, the Java completed filter, and why it doesn't work well. And then we're gonna talk about the virtual threads itself, how it's work, and then we're gonna talk about how a good use of it, and when these virtual threads do not work, because we have a scenario that virtual threads don't will work well. So let's begin with the introduction. The virtual threads were introduced on the JIT 444 by Alan Bateman. I don't know if everyone knows what a JIT is. It's a Java Enhancement Proposal. It was a proposal to create a feature that will use better the hardware, because one of the problems of the JVM today is we not use all the resources we have from the machine, because we have one characteristic from the threads is one thread by resources, by request, sorry. And this one thread by request block the thread and block the thread from the CPU. And then we don't use the full resource that we have on the machine. We lost a lot of time and resources. This is the proposal that Alan Bateman sent to us that will resolve this problem. But first of all, let's discuss about the problem. Let's understand how it's worked today. Okay? So today we have the thread by request. What is a thread by request? Let's imagine you have a Spring Boot application. You have a request came from users. Each request from the users will create a thread on the Java Reaper memory. And then this thread will communicate with the OS thread, and the OS thread will communicate with the CPU thread. And this will be a problem. But let's see a picture of it to understand better. So this is the JVM. First of all, what we have here is the run. There's going to be a request. So the request will create a stack. What is a stack? A stack basically is a queue, a FIFO, first in, first out of commands. So for example, you do a request for a get user. The get user will access the get service, the entity, and go into the database. So the thread will execute these full commands. Some of these commands has external dependencies, like consulting a database, consulting an API, for example. So imagine this is all a request from users. And these users will create threads on the Java heap. So what's going to happen? The JVM will say to OS thread. Remember, the JVM was created to be out of the OS. Is not fixed on the operational system. So the JVM will manage the thread of Java for the operational system thread. So the JVM will create for one thread, and they will create an OS thread. And then the OS thread will truly execute the command on the CPU. They will hold the CPU, a core of the CPU, to execute the command. And then when this finish, it's going to say to the thread, it's finished. And they're going to say to JVM, is that finished? But what's the problem here? The problem is, let's imagine you have an API call that will take like 3 seconds. So this thread will say to the OS thread to execute this API call. And the CPU will do that. But when we execute these 3 seconds, the thread is blocked. This whole process is blocked. So we take 3 seconds of loss of a core of a CPU. So what's going to happen? So exactly what I say. For example, this is a database. It's a block IO or API call. When you do a query, the thread is blocking, waiting the B response. But the thread is there doing nothing. And what can happen? So let's imagine a scenario. We have a lot of requests from the users, but we have a long query that is taking too long to respond, and you have a lot of requests, and your thread pool is, we have threads waiting because we don't have more CPUs, because the CPUs is full executing the query and waiting for the query response. But we have some threads waiting, and these threads waiting going to the heap memory. In the heap memory, it will hold all these waiting threads, and the heap became longer and longer and longer. Then we have this problem. We have out of memory because we have a lot of threads waiting, because we don't have CPU to execute that. And then we have an error and your application crash. That is happening more than you can imagine. For me, for example, I saw this happen in production like 4 times, because a long query take all the resources, and we don't have more CPUs to executing threads, and then out of memory because our thread pool is full. This happens a lot. We have a solution for that. We have. On the Java 8 and the Java 9, we are introduced to the Java functional. And the Java functional give it to us the Java async that is calling Java completed feature, Java feature. This Java feature give it to us an async solution. Basically, we don't have to wait this wait time we have before that is waiting the thread to respond to execute another. This don't happen anymore, because this is the executor service of completed feature will take a queue of blocking and a queue of executing threads, and then the thread will be executing. When, for example, we block a thread like we have before here, they're gonna move this thread to the blocking queue and gonna get another thread to execute on the CPU. So the CPU is not more just waiting. They have they'll be executing something always. So always will be executing something. We don't have more idle times on the CPU. It's perfect. So this is the solution we needed. But we have a problem here on the Java future. Is the complexity. Because Java future will need to change a lot of things. It's a completely different way to programming from the Java sync to the Java async. For example, today we have the that is completed feature, the Java, the Spring Flux, but it's a completely different way to do we have to the applications today. And the case is here, we need refactoring, and refactoring is complicated because normally it takes time and money, and it's very difficult to someone approval that, or some company approval that to refactor everything just to fix a problem of delaying, of to use a better research, because it's cost a lot. And we have another problem. It's changed a lot. So your team, your teammates is totally used to programming Java sync. So to change to a different way to use functions, to use async paradigms will be a very hard, and will take time to everyone to learn that, to start using that. So we have a big difficulty to use this solution. Because of that, on Java 9 and Java 8, no one was using, because it's very complicated to change everything. So in Java 19, we have the JIT 444, the virtual threads. But what's the proposal of the virtual threads? The proposal is that approach don't will require any code change. So the virtual threads, to use that, you don't need to touch on your code. The change will be on the JVM side. The JVM will change all the way the managing the threads. So remember, without that, basically one thread, Java is one JVM thread was one OS thread, and this was one core. The virtual threads change that. Will change the way we do this manage of threads. But let's understand exactly what is changed. Do you remember, do you have the JVM threads? The JVM threads that is communicate with the OS threads, it will change to the platform threads. So the platform threads basically will be executors. Do you remember that I said on the Java competitive feature, we have the executor service? Basically, the platform threads will be exactly the same as the executor service. And the virtual threads, like we said, okay, can you hear me? Okay. The virtual threads, like I said before, it was they are virtual, so they are not a really threads. They don't will execute the thread itself. The platform threads will execute the stack. The virtual threads just will hold the stack. So do you remember the stack that is a queue of a FIFO, that first in, first out? The virtual threads will just hold this stack. And the platform threads will execute these threads. But and then the platform threads will go to OS threads and will go to the CPU. But just to understand how the platform threads works, the platform threads will hold one virtual thread, and then when they go to the OS thread and execute it, they have a green sign of the CPU that was executing. They unmount the virtual thread. They will move this virtual thread to a queue of a block virtual thread, and then get another and execute it. So basically, we're gonna have they're gonna work like the executor service of the competitive future, but this will be like a black magic for someone is using, because you're gonna see anything. Like you're gonna will touch on the code, but the way the handle of threads will work perfectly. Let's do the first example. So we have, for example, external query search that will take time, and the virtual threads will get the response and get to the next command, like this picture here. So we have the OS thread, that we have the platform thread, that we have the virtual thread mounted. When the OS thread say to the platform, this is executing, they're gonna unmount that and move to the block virtual threads and get another. So you don't have idle time here. This is the good use, because we have a block where this block will happen, like I said before, like API call, a database query, something that need external command that will take time. Let's show an example. After that, if someone need to see the example, it's gonna be on the GitHub. I'm gonna show here how it's gonna work. So let's move it here to the IntelliJ. Okay. So here we have a sample application of a Spring Boot. On the Spring Boot 3. I think from 2.5, we have a new property that is calling Spring Thread Virtual Enable. By default, it's false. So by default, it's false, but you can set to true. This application is a totally simple application that will have a user model that will have handle some user data. We have a repository here to consulting on the Postgres. We have a Docker Composer to up here a Postgres on local machine, and basically it's gonna what could they get our users gonna do for us? They're gonna thread sleep will simulate exactly a API call, because API call basically will do a thread sleep to the thread, because they're gonna wait for 3 seconds. For example, we're gonna wait for 3 seconds here. And then you're gonna choose the repository and find everything. So let's first execute on the older way. For the tester proposal, we are limited to Tomcat threads to 8, because of course, if we need to show here the threads fully. If I don't limitate that, I will basically broken my computer. So this is not the case. So let's just limitate to 8 and see how things work. Let's up this application. Sure. So now let's execute a hey command. This hey command will do a 32 executions on the same time to the endpoint. Let's see what's gonna happen when you have a normal thread. See, we have 8 executions, then it's wait to the finish. So more 8 execution, it's wait, more 8 and wait. And then we have the response. It took 12 seconds to execute everything. And we was able to see how the block happens. Basically, they execute the 8 first request, then the other is waiting until finish. After finish, they get the other 8 and execute. So we have an idle time for the CPU waiting for the finish of these 3 seconds. But what happened when you change to true here? Let's see. And let's execute the same command. Don't change anything in the code. See? We don't have more this blocking time. They execute everything basically on the same time. The response time was 3 seconds. Why 3 seconds? Because it was the blocking that I put here. The 3 seconds is the time that takes to finish the thread. But when we block a thread, they get another virtual thread. Basically, let's go back to the presentation. This is exactly what happened here. That's exactly what happened. So when we finish, the virtual thread finished and it was blocking because we set the thread sleep. It's moved the virtual threads to block the blocking queue, and then they mounted order to not have idle time, but it's too fast, and we don't see any time wasting on execution. But basically, is that what happened in what we saw? And on the old case, we saw the blocking, the time that waiting for get others executions. So this is the perfect use of the virtual thread. But why when this is not a good case? When you have a too fast operation, not a block I/O. For example, what is not a block I/O? In-memory operation. So basically, we're going to do aggregation we're going to do, for example, I'm going to do a sort of a list. We're going to do a reduce, something that will use memory operation. They don't go to other third-party operation like database, API call, or other things that you can imagine that will request more time, or a block I/O, or read a file, for example. But this will take a time because it's need to waiting for some finish. But for example, on this example I'm gonna to show now, we don't have this wait because it's on memory operation. In a real time, a real case of use, we can imagine, for example, a real-time operation. Maybe you have a real-time operation that will just do aggregations on memory. Probably virtual threads will be a good case. But let's show this thing happening. We have a scenario here on the same application that is the bad use. But the bad use will block the query. We'll just do a reduce of a list. We'll sum everything and return. So you don't have a real blocker here. So let's first see what happened on the old case. We're going to use the same way we did the test before. Let's use the hey. But you're going to call the bad use endpoint. As you can see, you don't have any blockers. So the execution was fast. And we didn't happen a waiting case. And the execution time was 0.14. Let's see with virtual threads. With the same endpoint. See, we have a little one, but it's not much. We do not change anything. Or sometimes, if you keep executing that, probably virtual threads will lose time, because in some of type of operations, virtual thread, because they have to managing the threads, managing everything, mount threads and mount threads again, will take longer than the old case. So virtual threads will not own much thing here. This is the bad scenario. Well, basically, guys, what is the conclusion about virtual threads? Virtual threads will help us a lot in case of what we have the most on the business scenario is API calls and the queries or blocking IOs case. So if you have application that do, for example, a BFF that is do a lot of API calls, or if you have application or a microservices that is consulting a lot of data from database, virtual threads is perfect to you. If you have, for example, a real-time operation that do a lot of aggregations in memory, that do a lot of things, this is not the case, because it's not will help you a lot, or probably don't help you anything on this type of applications. But the virtual threads came to help us to kind of bring Java close to languages like Go, like Node.js, that do a better managing of the resource. So virtual threads will help us a lot on this case. Right now, I'm gonna open to questions.
Great. Thank you very much for your presentation. Really interesting was to hear about virtual threads. So before we proceed with questions, just a small question from my side. So did you already have a chance to try virtual threads in production, and what were your experience from that?
I have tried on microservices before, and it was very good. I didn't have any problem on production. Of course, now that is not on preview anymore. We waited to exit from preview. So on Java 21, it's a final version. So it's safe to use on productions. Was a very good experience because we won a lot of time. It's not just I show example here that we won like more than 6 seconds of execution, but truly we won a lot of time on these executions. That is totally true.
Okay. Yeah, that's really great to hear, because I can say that on my project we plan migration for Java 21 only next year. So I really exciting about this migration to virtual threads, because we have a lot of stuff in written on Webflux. Obviously, you also mentioned that in your talk, and we have this question in it's not a question, it's like, just a comment in our chat. So like yeah, it was an alternative, but yeah, I'm really excited that we can remove all that stuff and write everything to virtual threads. Question from one of our listeners: in our experience, in order to really have the benefits from virtual threads, the code changes still might be required in your code or in the libraries to use. Example, to avoid thread pinning. So what is your opinion? Are there like a lot of changes required for initiate virtual threads, or just some like small configuration changes?
No, but the changes is minimized by virtual threads. You don't need to change much things. Yeah, this is the benefits of the virtual thread. You might not require your code change, just libraries, and if you're using, for example, Spring, you just need to update your Spring version, upgrade the Java version, and then set a property. Just that. You just need to do that to use virtual threads. It's too easily. I have experienced that we need to change, for example, to Webflux application, that we change from Webflux to the application was for a BFF, and we need to change from Spring Boot Classic to Webflux, and it was too hard because the people was a change of mind to everyone. So to everyone learn, everyone needs to do a course, need to do a learning time, take like 2 hours of the day to learning Webflux, and then we can change that. It was too hard and costly to the company. So virtual threads is much better in this case.
Yeah, well, nice to hear. By the way, that's really impressive, and really nice to hear that finally Java is like, have some human face. So you not only need to like write a lot of stuff, but you also can just enable new feature, and it should work. It should work. So guys, if you haven't tried it in Java 21 yet, I do recommend you to do that. Some philosophical question, right? So we always on Java conference have people from other stacks, and they come and ask questions. So obviously in .NET, these thread syntax is really simpler. So they have async await, and mostly the same we have in JavaScript, etc.
Yeah.
So question is kind of philosophical. What do you think? Will we ever have in Java syntax like that?
Oh, we should. But if we think in Scala has a very easy way to handle that. And I saw on the old versions and the new versions of Java that we are giving a lot of features from Scala. For example, we have now the vars, so the implicit variables that came from start from Scala and move to Java right now. On Java 11, we already have that. So a lot of features that is moving to that. I think on the future, probably we're going to have a keyword called async, and this become async. Of course, we have some features, for example, from Spring, we have annotation async, and we can bring that to async. It's not a really async, but it's a start of it, you can say. It's not no work like Webflux, but it's a start of it. I think in the future probably we're gonna have a Jeep that will say to create a keyword async and make everything async more easily. Probably or sync because need to be sync sometimes. Will help a lot, of course.
Yeah, so as you mentioned that about this, not everything should be in sync. So for last, I think 5-6 years, as sorry, as Webflux and Reactive Stack is here with us, a lot of libraries and a lot of frameworks were adapting to this reactive stack. So we basically have now a lot of libraries like Mongo library or like Postgres library, like normal one and reactive one. And same for mostly a lot of libraries. And now when we write code, we should always think about which we use and if we communicate correctly with database, if we communicate correctly with other service, if other service basically support reactivity, is front-end support reactivity with RSocket or whatever. So what is your opinion? When we all, hopefully we all will migrate eventually on virtual threads, would we have something same, or we finally would have something unified and we ease our life in use all of that? What is your opinion on that?
I think it's closed, but I don't think so. It's gonna be so fast. Like, of course, we have now virtual threads that will help us a lot with the black magic, so don't need to change nothing. But for example, for H2DPC, for example, is a very good tool to do async calls to database. But to have a unify of everything, I think will take a little time. But we're gonna have a help, for example, from Spring Boot, because if Spring Data will, for example, the Spring Data adopt that for just a property to use the async or not, will be easily. So I think it's possible. It's possible, and the future is that, because we cannot just stay on a word that we just do sync. We need to move to async to use the better the resource, because we know that a lot of people that is playing about Java is the Java is low, the Java take much of memory, the Java is heavier because of that.
Yeah, I also I wait for this time when we stop joking about that. Yeah. So meanwhile, we have a question. Yeah, guys, just if you want to ask something, post it to the YouTube chat or chat on video community platform. So, question from Alexander: can we have virtual and all threads in the same project in parallel? Virtual for one endpoint, classic for another endpoint.
No, for the same project is impossible right now, because the virtual the application needs to work with the JVM with the virtual thread management. So we cannot have one endpoint with virtual threads and another endpoint with another. Probably you're gonna need to split in two microservices, and one is with false for virtual thread, and one with true for virtual thread. But
To be honest, I
together
want
it's
to
not
ask.
possible.
Yeah, thanks for answer. To be honest, I want to ask Alexander back why he wants to have this, because basically the whole idea of virtual threads is that we would substitute the normal threads and nothing would change. So basically, the idea is that all threads are really heavy and we have to connect them to operation system. I'm not sure if you remember, I'm too old, that we have to calculate how many threads we can run simultaneously, and then thread executors come in place. So the whole idea of virtual threads, as we don't need to think about that. You just run thread and it's there for you. So yeah, if you have real example why you need both type of threads at the same time simultaneously, so just tell us. Maybe it's really interesting, so we can discuss that.
I was thinking here. I don't think so. We have a way to use that in parallel. I don't think so. Maybe he was thinking about we need a sync case, but it's not the way we think on Java sync case, because they not will handle, for example, maybe he was thinking of the parallelized paradigm, that if you run API call that we'll need the second one, we'll need the first one result, but the Java virtual threads will handle that for us. We don't need to handle, because of course, when we think a JavaScript and we need to wait the first API call to call the second, we need to do a idle or a for comprehension, something like this. But for virtual threads, we don't need that, because we have the stacks. Do you remember that? And the stack will be on the same application. So the virtual thread will handle the stacks, but it's not in parallel. That's the important thing. Maybe one thing we are, and this is a good case, it's opening in my mind right now, is virtual threads not paralyzing your calls. That is the truth. One thing that is important. That is not paralyzing your calls. They are just paralyzing your stack, not your calls.
Your code. That's absolutely true. One more question from Carlos: would be any impact, positive or negative, when using completable future with virtual threads enabled?
Well, for sure they will have a positive, because for sure they will change nothing. That is the truth. They will change nothing, because when you're using the computed future, they have the executor servers, and the executor server is really a sync. So basically, if you move to virtual threads, they're going to execute things as a sync too, but on the thread management, don't you change anything to you, basically.
Yeah, just want to join Joao here. So all these completable features and async annotation in Spring, basically they are working on threads, and they just ease the management of threads for you. So if you move to virtual threads, that would be basically the same. You will see the same functionality, but most probably it would be more lightweight, I would say, and more easier for framework to work with that, and maybe easier for resources. So definitely have to try. Okay, I assume that's it with the questions. So, Joao, I want to say muito obrigado. Thank you very much for your talk. Thank you very much, and hope to see you on other Java conferences. Thank you.
Thank you for everyone watching. Bye.
Bye. Oh, we're on there already. Love this song. So, guys, we are on Java On, halfway through day 3. So we're proceeding with all our activities. We have 2 more talks to listen, and we have a small amount of time. So I want to remind you about our activities we do have. So let me share my screen and show them to you. Yeah, I need to do a lot of preparation for just showing you the presentation. Okay, I will manage that. I'm pretty sure. So, yeah, we do have the activities. So first one is you can go to this video. This is promo video of our conference, and you can leave a comment below this video. So you can tell us how you see our future conferences, what you want to hear from us, what you want to see, which topics are interested for you. So we want to hear from you. And through all the people who will leave their comments below this video, we will make a raffle, and you have a chance to win Java on T-shirt, and we will send it to your location. So yeah, take a chance to receive our special T-shirt, specially made for this conference. And yeah, this is your opportunity. One more activity which we also have is this one. It's Kahoot challenge. So you can go by this QR code, and behind this QR code you can find a fun challenge. There are some fun pictures there. So yeah, you can participate in that, and there you can also win the prizes. We have IntelliJ IDEA licenses for you. So we will make a raffle via all who would participate there and participate and take some higher places, of course. So participate in our Kahoot challenge. It's fun. Some fun pictures behind that, and then you can win these prizes. Yeah, so we especially prepared them for you. So also I want to remind you that our speakers, they want to hear from you, right? We are all in this online world for years already, right? It's quite hard to speak to the screen. So right now I'm alone in this room, and there is only my dog here. He is lying right below. He is a bit worried about me that I'm here alone speaking with screens, but I know that I'm not speaking to screens. I know that I'm speaking with you guys. So I want to tell you that our speakers also speaking with screens, and it's really hard to do that. So I want to tell you that you can make their life better. All you need to do is you need just to go to our platform. We are a community platform. So you either on the platform already, or you are on YouTube, and you can search for the link to the platform in the description. You can see the agenda here. So for example, we just had talk with Joao, and you posted comments for him, right? So you can just go there, click on the talk, and here you can say thank you. And you can rate his talk, and you can say thank you. So let's do it together, right? So I say thank you for your talk. You can select any badge, by the way. So muito obrigado. This is Portuguese, by the way, for your talk. Sorry, I'm not so proficient in Portuguese. For your talk on Java on 2024. And some exclamation mark, and give a badge. That's it. That's easy. So and also I want to say that you can see here Tanya as a moderator. So of course you can see me, I moderate all the talks, but we have Tanya on the behind, and we have all our team behind the stage. So we put her on some talks as a moderator for you to appreciate her work as well. So please give her some badges as well. Yeah, this is an ask from my side. So this is something I would ask you to do for me. So yeah, here also you can find all our agenda, and for all our speakers, you can give it, you can give badges, you can rate their talks. So this is something I really wanted to do. Meanwhile, we are waiting for our next speaker and our next talk. Can I ask you to share your opinion on the conference in the chats, and any chat you see more comfortable? So it could be chat on YouTube, it could be chat on VR community platform. So I want to hear from you. Tell me more. Tell me, do you like our conference? What do you like more about our conference? And yeah, anything you want to share, by the way, because as I mentioned before, this is really important. Like, do you like the conference or not? Like, just send plus. You like the conference, minus, like, just okay. But I do know you like our conference. That's why you're here with us for all this time, right? Right. Okay, let's watch video one more time, and meanwhile, please leave us your comments. So after the video, we will check them and try to see your reactions, and yeah, and see your opinion about our conference. See you there. So we proceed. I don't see a lot of feedbacks, but a lot of comments in the chats anyway. But still, we can. Sorry, guys. Yeah, I still have this Koch. If you want to know some insights about Java conference, so I drink tea mostly all the time because only some tea can help me not to bring these sounds in the air. And also here I have a humidifier because my colleague advised me that putting humidifier right near my nose would help me. So yeah, it's much better. Thank you for worry. So meanwhile, you're putting your feedbacks about our conference and putting your messages on how do you like our conference and what do you like about conference, we can do the following stuff. We can go to our to our YouTube, and there we can check your comments. Basically, we can check your comments on what do you like to know on future Java conferences. And surprise, surprise, we have special guest. Meanwhile, we're waiting. Tatiana is joining me in our virtual studio. Hi, Tanya. Welcome to Java.
Hello guys, nice to see all of you here today, and hopefully you're not so tired as we are, because we are a part of actually program committee who has prepared this conference for you for nearly 9 or 10 months already. So we started at the almost very beginning of this year to prepare this conference for you.
Yeah, it appears that if you want to grab top speakers for the conference, you have to do it really early in the year. So guys, Tanya is always on the backstage. She's helping moderate all these talks and all these chats. So thanks to her a lot. Like virtual applauses, and please give her a badge on the VR community platform. So Tanya, what I want to do with you a small activity. So I want to go through the comments people leave us on our YouTube below the promo video. So I will show it. I can share my screen right now. So let's just go through and see what people really want to learn on future conferences. So maybe we can pick up something interesting as program committee.
We will definitely do.
Yeah. So very first comment, like it's Java for AI and ML applications.
Actually, we have already covered that, but I think that during the year we will see a lot of new stuff around that, and we will be ready to tell you something new, definitely.
Yeah, even on the panel discussion which we have in the beginning of today, Evgeny Borisov mentioned something about the platform they are developing. So I do think that soon this platform will be available. Something for everybody, I would say, and we can share it, and we can share with you links so you all can play with it and try it. So I think it will be really great. So another dream topic for Java on Conf 2025, Java 30 years of evolution, string interpolation finally released. Wow. This sounds yeah, this sounds really interesting, to be honest, because like, okay, string interpolation, after 30 years, finally it's here with us.
So actually, yeah, but the progress come a bit slower than we might expect to us, but still, it comes.
Yeah. Okay, we have feedback on here, the Texan conference. Thank you very much. Really appreciate it. Fantastic opportunity to learn about late development, Java and AI. Yeah, I think we hit the crowd on this year because from all our topics, we have 4 about AI. So I think that's good, and people has ability to learn something really new and amazing, right? Okay, so
actually, I see quite a lot of Yep, let me interrupt you for a moment. I do see a lot of comments around the AI topic, so let's possibly try to find something unique regarding that, because, yeah, basically they sound kind of similar. And actually, yeah, this definitely shows the trend which we have in the industry. And basically, that's interesting that guys would like to know more about the development itself, but they do not clarify whether they would like to know more about the productivity area, so how to make your own work productive, or about the actual business solution. So let's possibly try to find out whether. So there are some clues on that.
Yeah. So, guys, if you can leave us more hints about what exactly you want to learn about AI, if you want to give us some hints what exactly you want to see, learn, listen, anything, that would be really amazing. Because AI is a quite huge topic, so a lot of stuff is in there. So that would be really cool to see more details in your comments. I mean, of course, we hear as just general what you want to listen on future conferences, but yeah, if you can give us more details, it would be really, really good. So yeah, I'm super excited to join the conference. Thank you very much for the chance. My dream topic will be authentication, both basic auth and JWT tokens. Keep up the good work. So people want to know more about secrets, and in addition to what yesterday Istvan shared with us, people want to know more about tokens, authentication certificates, etc. Well, that's really, really cool.
That's absolutely fantastically correlates with the topic of AI, because actually taking into account that definitely we would need to upload our data somewhere in order just to be able to handle all of that huge stuff in some cloud machines in order to process it with AI. Definitely the point which also has been mentioned today is about the privacy and security. So this is clearly understood that guys are interested in the topic.
Yeah, and I think that security topic is really underestimated because we always focus on these new features. We always focus on that. Okay, how to do that? How to do this? How virtual threads will help us? But basically, there is a huge elephant in the room. And for the last 3 years, I work on a project where the whole our work is basically related to certificates, tokens, etc., etc., etc. And our customers, they are really crazy about that, I would say. So if some certificate is out of control, something is not prolonged in time, that's a great disaster. So I do think that this topic is really underestimated in Java world, where we work more with backend, with enterprise. Yeah, it's really something we need to share more for sure. So great conference. Thank you for this content. Would like to hear more on event-driven APIs versus REST APIs and any new tool, tips, design patterns. Wow, really interesting as well.
Actually, I'm so excited to see such comments because I truly like to hear about some purely backend stuff related purely to Java in this modern world of fancy technologies. And seeing that somebody else also wants to hear about that, I'm truly happy that I'm not alone, actually.
Yeah. 100% agree. Okay, so good job, and looking forward for this year, and I hope for next year as well. I would say possible topic for Java OnConf 2025, top tech trends for 2025 prediction session, a broader session covering prediction for AI, 5G, Web3, blockchain. Wow, it's quite huge range, I would say, not only related to Java. And where Java fits into these trends. Okay, here's Java comes. Could get into these forward-looking insights, and also Java and AI integration. So yeah, I do hope the Java and AI integration we did cover yesterday with talk of Przemysław, so you can check it. Recording is available. And regarding top tech trends, yes, I think we can add this for next year.
Actually, I took a pause to think about the latest point about the AI and machine learning. So basically, we talk a lot about the generative AI and around it and how to use it and how to use large language models and how to process images and all of that fancy stuff. But we possibly do not dig deeper into the machine learning area yet. This is definitely the topic which is developed for a lot of years already, and it definitely needs a separate conference or a series of conferences to be covered. But that's an interesting trend that people would like to know more about that, would like to know more about what happens behind the scenes. And basically, I think that this would become the broader knowledge soon. So, which is interesting, like shift of the mindset.
Yeah, absolutely true. Absolutely agree with you here. So, would be great to see a topic on practical tips for design high performance REST APIs in Java, including efficient serialization, response optimization, and handling high traffic. I think this is really something next step after topics we really we discuss here, and people want to know more in details and in depth. That's really cool. That's really amazing.
Yep, and I hope that some of our participants, possibly even the ones who have posted these questions to us, are also interested in participation as a public speakers. And in case if you would like to do so, we would be happy to see you as speakers on both our huge conference where we are right now, and hopefully we will meet again each other. And actually, we could also give you a platform to take part as a public speaker between our conferences, because let me remind you that one of the key organizers of this conference is Jacob community, which is always ready to give you a chance to become public speaker and tell more about your expertise and knowledge. So please just contact us, and we are always looking for great speakers.
Yes, and on this YouTube channel, you can find our webinars, so subscribe to it not to miss them. And yes, we always encourage you to become speakers in our webinars, so it would be great to see you there. So I think it was really great to read all these comments. Tanya, thank you very much for joining me here, and we are ready to move to our next speaker.
Thank you.
So Tanya, yeah, thank you very much. So let me invite here to the stage our next speaker. This is representative. Well, yeah, she's our former colleague, by the way, but still, she is representative of Testcontainers at Docker, Anna Chernysheva. Anna, welcome to Javon.
Hello.
Hello, nice to.
Hope you can hear me and see me.
Yeah, I can hear and see you. And by the way, I just have the same AirPods here.
Oh,
the same color.
I can recommend. I love them. I love that. It was very good purchase.
Yeah, I just love them. I just decided for the conference to switch to AirPods, my hair. So like this. Okay, so can you give us a quick hint what your talk would be about?
Yeah, so my talk will be about test containers best practices. I think that a lot of people here already know about test containers, open source. We have a very big community, but I want to highlight some best practices of how you can use this library in Java, what guidance to follow, and share some useful links for the folks who want to leverage their integration testing.
Sounds really great. So I would ask you to start sharing your screen. And meanwhile, I would remind everyone that you can leave questions for our speakers in the chat where you're basically watching us. Could be YouTube chat, could be chat on VR community platform. I will collect all your questions. I said answers, right? I will collect all your questions and ask them in the end of the talk. So guys, don't miss this opportunity to ask anything you want about test containers because I'm pretty sure most of you are using them. So Anna, stage is yours. Good luck.
Thank you. All right. So let's start. Brief overview of the talk. I want to first cover what is test containers for those people who don't know about it, how test containers impact developer productivity and speed, and then we will cover 8 best practices that is a good way to follow when you implement test containers for your integration testing. So first of all, quick introduction. I'm Anna. I work at Docker. I'm solution engineer right now, and I joined Docker through the acquisition of Atomic Jar. That is the startup behind Test Containers and Test Containers Cloud. And before that, yeah, as Roma said, I worked for EPAM for a long period of my career. So probably we'll see some familiar faces in the chat when you ask questions. Okay, so about developer productivity and how test containers stands here. I want you to think about what drives your productivity. You can also put this answer somewhere in the chat if we have it. And when you reflect on this topic, usually answers that we get during these conversations about developer productivity can be aggregated in 3 main headlines. Is first, cognitive load impacts your productivity, feedback loops impacts your productivity, and in general flow state as a combination of these first 2 impacts your productivity. Cognitive load means that when you use Slack or when you use Teams, emails, whatever, you may be distracted from your workflow, by colleagues who ask some questions. You want to answer them right now, so you switch the context. Or you open a new project, you see that it requires refactoring like immediately. It was like not good, and you again switch the context from the top priority tasks. Another bullet is feedback loops. So you want to iterate fast, and you want to get the joy from the development because it's cool, it's funny, it's really great to be a developer. But when you want to get the feedback on your code, on the feature that you implement, you want to get it fast. And if you need to wait for it, like for example, push it to another pipeline stage, wait for a couple of hours, or even less than an hour, but still you have to wait, you will switch to another task. Then you get the feedback about your initial task validation. And if there are some issues, you need to switch and fix them. So you are always in this context switch, which means that being productive is hard in nowadays. I put here link to article, like I liked it some time ago. It describes in more detailed way the productivity issues, and that when you have this constant context switches, you change from your attention from one task to another, from writing the code to fixing the flaky tests. You get this context switches and you can't get into the flow state. Also, based on this article, author says that after approximately 15 to 30 minutes, you get into the flow states, and this is the state where you really enjoy what you are doing, where you can feel your productivity, you are focused, nothing distracts your attention, you can accomplish the tasks, and after the day of this productive work, you can say that, okay, I'm happy with what I'm doing, I was very productive, I implemented great features, everything is fine. So the faster you get the feedback, the more productive and more happy you may feel. So the feedback loop often struggles with the stage when it comes to the integration testing. There are different approaches how you can do it. For example, you want to test your application against the database, you want to test it locally, and you can install the database. You can have H2 configured with your project, or like you can use some mocks to imitate another service in addition to the database. But still, it will be kind of fake. And when you push your code further in the CI pipeline, your test may fail because it works with H2, but it doesn't work with real Postgre. Or the worst case scenario, there will be some critical defects in the production. Another pretty popular way of doing integration testing and trying to speed up things is having shared instances on the staging or QA environment. So, for example, you have the same Postgre on your staging, you run your tests, but let's say another team is running tests at the same time, and you end up with flaky tests because another test rewrite the test data in your Postgre, and there were no data that you expected to be during your test scenarios, and you need to go and spend some time, understand why tests are failed. Either it's because of some bugs, or is it because of just the flakiness and issues with the test data. And this approach, it again slows down the feedback loop. Or like another case is test in production, but we will not focus on it. It's pretty rare, but still used in some organizations. So how test containers and in general integration testing was transformed with this approach of running tests locally or on staging, like how we can do this. So first, when Docker come into place, we were very happy because we can run things in containers. So we can run Postgre in container, and we can run it locally without downloading the real instance on the machine. And we can test things with different versions of Postgre, for example. Next thing, if you want to run more complex application with not only Postgre, but start our application with Kafka and other dependencies, we can go with Docker Compose and define what services we want to start with our application. Again, run it locally, test things. But the next approach, which is Testcontainers uses as a baseline, is Docker API that helps you to make your tests more developer-oriented and more flexible. So here we come to stage of introducing test containers. You can think, so this is the open source library, and it provides you with real instances, like with lightweight instances of real services, like real databases, real message brokers, put it into Docker containers, and you can access this services through the programmatic API. So you can think about it as programmatic compose. You just define what you want to start, like in this case, I have Redis example, and you have your Redis up and running. This is pretty convenient, like we have a big community, more than 30 million pull per month from the Docker Hub, and we have a lot of public cases from Spotify, Netflix, Uber, etc., talking about how they introduce test containers to their integration testing. So how it works? You can think about it as a high-level Docker DSL because it is based on the Docker API. The one requirement that you need to fulfill when you run test containers test is to have Docker available, like the Docker context, so your tests can start the containers. In your IDE, you define what you want to start, and when command start is executed, it will be interpreted into the Docker command that will interact with the Docker host, with the Docker daemon that's running on the Docker host, that will pull the image, start the container, and gives to your code information about this container, the port, the host, environment variables, etc., like everything that you can get from the Docker container. In this way, you can make your test self-contained. So you can still be in the inner loop. You can get the feedback real fast. And you can, by spinning up real services, like real environment that you need for testing on your local machine, this environment will be the same as you use in production. It will be on demand, so test containers by default looks up after your containers. When you start test, containers will be started. When tests are complete, containers will be automatically destroyed. So you don't need to worry about resources. It also starts container on the random port, so you don't need to worry about what ports are available on your machine. You can just leverage your environment setup for testing to test containers, and it will manage all the things for you. So the best practices. Let's start with the first, actually two. They go very close together. Maybe a bit obvious, but let's go with examples. So first of all, we recommend not relying on the static host and port. So do not hardcode these things. And let's look why. Let's switch to the IDE. So here I have an example of Redis. This is how you can set up Redis with generic container. It exposes the port, and let's say I just introduced that container to my test stack. And I had this connection to JD's pool. So in my test, I want to connect to Redis. I want to put some values, and I want to get these values to understand that connection works properly. Like very, very simple thing. How do you think would this test run or not? Let's run it. All right, it's failed. Let's take a look why. Connection refused. Yes, we can't connect because of the hard-coded port. When you use test containers, the beauty of this technology is that you get information about container in your code, and you get it on demand, like live. So you can say here, Redis, get mapped port, and provide here the port that you want to get for what's wrong here? No, something is with my ID. Oh, I used get first map pop. Just get map port. Yeah, you can actually go with first map port here as well because this is only one port here. If we run this test again, you will see that it is green. Yes, now we can connect to Redis and verify things here. So you may ask why we shouldn't leave the local host here. We can. Test will pass locally, but if you run your tests in CI with the connection to remote Docker host, they will fail because there will be no application available, like no Redis available on the local host. So the same thing here. We can do Redis get host, and in this example, it will get the real host where Redis is running, and you will be sure that your connection is stable. So coming back here, yeah, don't be default with it works on my machine. It should work everywhere, and just utilize Testcontainers API to get the information about the containers. And again, yeah, if there is only one port that you expose, you can get the first map port. It will also work to get the port of the Testcontainers based container. Let's go to the next one. Again, pretty obvious, don't hardcode container name. Let's take a look what will happen if we do this. For example, the same Redis, you want to run the container, but you want to be sure that this is Redis. So you want to say, this is my Redis container. You can do it like this with Testcontainers implementation. So just execute the command inside when you start the container. So here I have two tests. They just put the value into Redis and get the value, and I start container before each test. Like, let's say this is my use case. I want to do this. Let's take a look what will happen. I think you already guessed that one test will fail. Yes, and it fails because the image conflict. So you can't start two containers with the same name. So if you just remove it, you will see that tests are green, and each of my tests, it logs the container name. So here you will see that there were two different container names used, and like this is fine because we can get the container name using Testcontainers API. So if you want to know the name of your container, you don't need to hard code it. You just need to ask Testcontainers to give it to you. So yeah, here, if you want to run your containers with the same name, here's how it may look like. You don't know if there is a GDI or if it's an evil in this like covering under this same name. Yeah, so don't hard code. And again, as like the general rule of thumb, if there is no Testcontainers API available for some type of Docker feature, then it is intentional move. So Testcontainers provides the API that follows the best practices for testing, for integration testing. There are some cases probably where you want to use some Docker features that are not available in Testcontainers API, but this is usually the rare cases. And we suggest following the API that is available, meaning that you will follow the best practices by default. Okay, the next one, again, pretty obvious, but we still are seeing this implementation in some test cases because it's like the easy way. You can use sleep to wait for container and then move forward. It's like just one line. But let's take a look how it may look differently. So here I have example, the same Redis and another Nginx. Let's say I want to test something with reverse proxy, and I want to start my Nginx after the Redis is starting. I can use thread sleep. It's pretty easy. 2 lines of code. I start Redis, then sleep, start Nginx, then sleep, and yeah, this should work. And actually, if I run this test, you will see that they work. Containers are started. Yeah, it's like 7 seconds, close to 8 seconds. Not that big difference. But let's take a look how we can do it differently. So there is waiting for method like API, programmatic API that is available in Testcontainers that gives you a wait strategy that you can utilize to wait for container. So here in this example, let's wait for the log message. I have it here. We know that when we start Redis, it should give the log message that it's ready to accept connections. And the same for the Nginx. We can actually put the rule annotation here and say that it depends on Redis. It means that Redis, when you start Redis container, Testcontainers will wait for this log message available, and when Nginx container will be started, it will start with the rule that it depends on Redis. When Redis is available, then Nginx will start. So we can delete these 2 thread sleeps and run tests again. And it was like 2 seconds. So this is just for one test. 8 seconds with thread sleep and 2 seconds, like let's say close to 3 seconds without, just with the wait strategies. But if you have not 1 test, not 10 tests, even like not 100 tests, but like more than 100 tests, like the big test suite, and in every class you want to wait for containers to be started, the wait strategy will help you to speed up your testing. So if you're using thread sleeps in some places, take a look at the wait strategies that are available in Testcontainers. There are plenty of them, and they may help you with reducing the time of your tests. So yeah, don't wait for tests, just use wait strategies. I provided here the link. I think it will be shared after. I can share it after in the chat as well, with detailed list of the wait strategies that are available in Java Testcontainers implementation. So here I use just the simple one about the logs, but you can combine them. So for example, if you want to wait for some port being available and for some log message being present in your container, you can aggregate these two into combined wait strategy. So your container will be considered as fully started and available for your tests only when these two conditions are fulfilled. You can also do more complex health checks, call some APIs, input some command messages, or like execute some commands in the container and wait for response. A lot of things that you can do, just use proper wait strategy. The next thing is related to generic containers and the modules. Let's take a look what I'm talking about. So the basic construct in test containers is generic container. This is the basic class that you can use to start your containers, like any container. Here is an example how you can start Postgre with generic container. You provide your image, then you know that if you want to start Postgre, you need to expose this port. You need to provide environment variables like username, password, database. You can copy files to container with your test data, and you want to wait. Here is another example of how you can wait for container to be ready. So it's log message strategy. You want to wait for this log during like this period of time. Then when container is started, you want to connect to it. So in your connection, you just specify the JDBC URL. You can get it from the aggregation of the container host and container port. And then you provide username and password in order to connect to this Postgre instance. Then you can execute your tests. Here in this example, I just, so I have this init data here. It just creates some to-do list. And I verify that it contains from like proper amount of completed to-dos. Simple thing. I can run it, it will pass, like, all good. But if you want to use Postgre not only in one class, but in multiple classes for different test scenarios, you will need to copy and paste all of this stuff. So test containers has modules, which is the high-level abstraction over different technologies. And we have Postgre module. So you can just start the Postgre container. You say it's new Postgre container. You can put the image name here. You can, again, fulfill it with the test data. And we can, let's actually remove it and name it Postgre. So this is how you can do the same thing with Postgre module. Next, you want to connect to this module, right, to the Postgre. So you don't need to do this complicated things with get host, get port. You can do just Postgre get JDBC URL. You can do Postgre get username. Put comma here. And Postgre get password. This is much more easier way. So if we run the tests, you will see that everything should be good. I think I didn't do any typos. Yeah, all good. You have your Postgre instance in like 3 lines with predefined data. And it's very easy to connect to it. You don't need to remember what was your username, what was your password. You just get this information from the container because it is already implemented in this module. So if you go into implementation, you will see that this JDBC data container extends generic container. So it's kind of more high-level abstraction that already stores some information about how you start Postgre. And it relates not only to Postgre, there are a lot of different modules available. So the more bright example is with Kafka. So like if you want to run Kafka in generic container, like you may end up like this, because you need to know information about Zookeeper, you need to know information about hosts, ports, all of these relations. And if you want to migrate Kafka start from one test class to another, it's a nightmare. But you can use modules. So this is just a summary, and here I have a quick screenshot of the modules. You can go to Testcontainers official website and take a look what modules are available there, sort by languages, and we have also official modules program. So, for example, like CockroachDB, Dapper, these modules, they are official, meaning that the companies behind this technology, they are responsible to maintaining the module code in the up-to-date state. So most of the modules in Testcontainers catalog is community maintained, but those who are official modules, they are maintained by the team who developed the specific technology, meaning that if there is something new available, like in Dapper, then the team behind it will make appropriate changes in the module implementation. Let's go to the next one. Also pretty simple one, but again, I saw a couple of times people are using it. So when you run your tests, sometimes you want to run it with the latest. You don't want to scroll what is the latest tag, like what is the exact tag, or you don't know what is the version in your production, or it's in transition state. I don't know, you don't get this information. You want to run with latest. But this is not that good approach. So why not? Let's take a look at some example. Let's say you are using Mongo in production and you use old version like 3.6, and you are in the process of migrating to the new one, like 4, more than 4. So in the recent versions of Mongo, you can use transactions, and you can use it like to communicate with the database. Old version of Mongo doesn't support it. There can be like some confusions when you write codes and when you run some tests, and if you always tend to use the latest version, it may appear that you run tests with the latest that should not pass because your production version is still old. So if you run these tests with the latest version, you will see everything works good. Like you can insert with transaction into the table, all good. But if you change the Mongo version to specific one, 3.6, you will see that these tests will fail because Mongo 3.6 doesn't support transactions. And when you try to start the transaction, it will fail. So yeah, test failed. But if you use this code not in the test, but in the real application, there can be issues that discovered further in the pipeline or in production. This is just a very probably obvious use case, but there can be other use cases with databases where some types of operations are not supported in the older version comparing to the latest versions. And if you use latest, for your testing, everything might be good, but in production, some things may fail because of incompatibility of the operations. And yeah, let's not be folks with everything like it works on my machine. Let's think about the wider picture. Again, in general for testing, being specific is very important because you need to know exactly what you are testing, with what environment, with what versions, to be sure that everything works as expected with the proper versions that you use in your production code. All right, let's move to before each. In some of the previous examples with container name, I showed that I run my container in the before each annotation, which is not the best practice. It can be done for some use cases. So in this case, I used it just for demo purposes. Sometimes you may need to run it to, again, test some negative scenarios. Maybe some test case will fail your database and you want to be sure that another test cases will not be affected by it. But let's move to the lifecycle strategies. So I hear usually this question a lot about the proper lifecycle, how to optimize test containers usage, how to start containers in a more efficient way. So here I want to show a couple of examples. So again, before each, not a good practice. Let's start container before the class. How you can do this? The same like Postgre example, but here I have like very tiny implementation of my customer service. So I have a customer with ID and name. I have customer service that can create customer, get customer from database, get all customers, like all of this stuff, and my database connection. Very, very simple, not Spring Boot oriented, but to make the demo clearer. So you start your Postgre as a static, which means there will be only one instance of Postgre available for this class. Then in before all, you just say start, you can have your connection, and after all, you can stop it. This is very manual usage of the test containers lifecycle. So here you see the tests are passed, like all good, but no before each. More interesting things are here. So in the JUnit 5, you can use test containers annotation with the container annotation. So here I put it test containers annotation above the class. It means that it will look for container annotations inside of the implementation and will start test containers that are marked with container annotation. So here I defined it once, and before tests, I just create the connection, delete all the data to have the state clear for each test. And here I print the container name in my two tests. Let's run them. Okay, tests are done, but you see that container names are different, meaning that with this approach, for each test was created its own container, which is not good, the same as before each. But if you do static, then only one container will be created for the class. it is pretty often mistake when folks are using test containers and container annotation. So it's important to remember then test containers look for container annotation. If the container is a static field, then it will be started once. If it's an instance field, then it will be started before each test. So here you can see container name is the same. So we started one container before whole test suite in this class. And another example, singleton approach. So here you define the abstract class with test containers that you want to start. Again, I have a Postgre example. If you have more containers, you can run more. Important thing here is to put them into the static block and start them in the static block. In this case, you will have one container for not class, but your whole test suite that extends this abstract class. So you start your Postgre, you can define your connection once, and here and before each, I just log the container name. I have two classes, like first one that extends abstract integration test, two tests that just create customer and get one customer, get all customers, and the same set of tests, like very similar, but with another test data for the second class. So let's run them. All right, tests are done, and you see that for my tests from two test classes, they used the same Postgre container. This way may optimize your test speed like dramatically. If there are test cases that verifies the positive flow, it is totally acceptable to have one instance of Postgre. You know, the test will not break it. They verify like some general flows, and you can have only one instance for the whole test suite. It will start once, and it will be destroyed after the whole test suite is complete. There is one common misconfiguration that we see when people use singleton. You can think of using test containers and container annotation for your container and do not use static. So you define it once, then you extend in your test class implementation abstract class with defined containers. Let's run them and see how containers will behave. Okay, tests are done, but you see here and here for each test class was used each own instance of Postgre. So in this implementation, test containers annotation rules the container, and even though containers defined as static, it will be applied for each class. So be careful with this when you implement the singleton. This is, again, we see that test containers and container annotation often raises some confusion of how it should be used. All right, let me delete it. Good. So no before each. When you use before each, your resources and test execution time just burns. You may end up with very long test cycles and then complain that test containers are not the proper tool because it works so long. Using the proper container lifecycle may help you with optimizing the test speed and like using the technology in the way it was designed to be used. Again, quick summary about before all and test containers plus container notation. Singleton, there is a guide on our page. I will show the detailed list of links at the end of the session. So there is a big blog post that explains one more time the best ways of using container lifecycle and what are the common misconfigurations are, so you can avoid them. And the last but not least, you can utilize the integrations from your framework that are available for test containers. For example, if you use test containers with Spring Boot or with Quarkus, Micronauts, all of these frameworks, they provide their own vision of how you can use test containers within their framework. Let's take a look at the Spring example here. So the test I showed before, they were a bit separated from the application lifecycle. It was just examples, how you can start containers, how use them, wait strategies, lifecycle, and so on. But the real example, if you want to run containers with your application, you want to tell your application to connect to exactly this instance of Postgre, not another, like not that one that is on your staging environment, but this one that is running with test containers. How you can do that? I have here pretty simple to-do app. It has to-do repository that can get pending to-dos. I have here to-do controller that can get to-do by ID, can save, can update, delete, and so on. Very like, just the base simple implementation. Let's say I want to test this application. First of all, I can start with the repository testing, meaning that test how my implementation works well with real database. If my repository really can put data in the database, get them properly, maybe modify. So here I can leverage test containers for the repository testing by using test property source provided by Spring. And in the data source URL, you just provide the connection. So here, important thing that you put the test containers in the line, and then you define what version of database or like what other technology you want to start. So here I have a couple of tests that will just save to-dos and verify that they are saved correctly. Should delete the to-do, I save them, then delete all, and expect that everything will be deleted from my database. So if I run this test, they should be good to go. All right, yeah. So here I used test containers Postgre database and afterward my implementation of to-do repository to test how it works. But if I want to test the APIs, there are two ways of how you can do this with Spring. If you are using Spring, like old version of Spring, less than 3, then you can go with dynamic property source. So what's important here? again, I utilize test containers annotation. It will start one container. I inject test data again through the Spring Boot SQL annotation. I have it here in resources. This is a bit of test data that I use for my test scenarios. And here in dynamic property source, I rewrite the Spring Boot application properties with the data from my test containers container. So I say that data source URL should be JDBC URL from test containers, that the username should be username from my Postgre container, the same for password. If you need to provide more information about how you want to start the Postgre, again, you can utilize Test Containers API for that. And then, I just need to define the port, expose it to test containers, and this test will start the application. I can call the endpoints of it and verify that things are working properly. So let's run them. Okay, it's initiated. Good. Test passed. Very good. If you're using Spring Boot 3.1 or newer, then you can use a more advanced approach of how to connect your application to test containers-based containers. Here's the same example, the same set of tests, but they look clearer. I just provide here the test data, and I extend in my test implementation the base integration test class. Let's take a look what it does. Here, the same thing that were in the old implementation. I need to get the port and I need to expose it to the test containers. The important thing here that I can import container config class where I can define my containers. In this container config class, I define Postgre, but I do not put the information about the container into data property source, into the data registry. I just use this service connection annotation. So the service connection is available in the Spring Boot greater from the Spring Boot version greater than 3.1, and under the hood, it just implements how your application should talk to this test containers implementation. So test containers team work very closely with the Spring team, and you can check that there are always some new things coming up with Spring because they recommend using test containers as a tool for integration testing. If you even go to the Spring websites and generate the new project there and select that you want to use some test frameworks there, the project will be generated with everything needed for test containers test to work. So coming back here to the implementation, once again, I have container config with service connection annotation that I can put under on my container. Then I just use it for the base integration test, and I extend my test class from this base integration test. In this approach as well, my Postgre will start only once for the whole test suite that extends base integration test. So let's run these tests and make sure that everything is working properly. Okay. Good. Test passed. Another advantage of this type of implementation with container config and like the service connections is that you can start your actual application locally reusing the same configuration and the same set of containers. So here I have an example of my test application, how I can start it. So I say that I start my application from the main with container config class, meaning with Postgre that I defined there, and like I just run it. Let's run it. So you see in this example, application started initialization. Okay, it is started, and I can go to like, the entry point. This is my application. If I go to Docker Desktop, you will see here that Postgre is running, and I can test things like in my test data, I have a to-dos table, and I have some test lines about my to-do list. I can mark them done or not done, verify the things in database further if I need to do so. So this approach with container config and service connection notation allows you to define test containers environment once and then reuse it for either local development use case or for your integration testing use case as well. Let's stop the application and come back here. So yeah, we have 4 minutes left. Let's wrap it up. Quick summary of what we discussed today. First, as a best practice, use available test containers API to start the containers, to get the information about the containers. If API is available, it means that it is the recommended way, it is the best practice of how containers should be started and what information you can get from it. There is also a link about how you can create containers, like the best practices of it. Wait strategies, this is important to utilize them in order to, again, speed up your test cycle, not to waste some time on just some waiting, but you can utilize native things from test containers to wait for your containers. Modules, again, if there is some module available, it's better to use it because either community or official maintainers contributed to the detailed implementation of how you can start your container. It will just save time when you reuse the specific technology. Latest, don't use latest. This is general rule for testing. Proper container lifecycle. A lot of strategies are defined in our blog posts, but again, don't start containers in before each. It's better to use one container for the test class or one container for the whole test suite. And yeah, leverage your framework's integration to utilize test containers. It just helps you to follow the best practices way of either your framework or test containers. All right, this is it. If you have questions, I think we will ask them after this session. There are some useful links that you can use. Test containers website guides that contains a lot of information that we covered today about the best practices and how to get started or leverage test containers with your framework. If you want to check another container runtimes, we have Testcontainers Cloud for that. And on the GitHub, awesome test containers, you can find examples of how you can use it with different languages, with different CI/CD pipelines, how to run tests, and so on. And yeah, join our Slack if you have questions. The whole team is there. They will be happy to help you with questions, with answers. Yeah, so thank you. And we are always open to questions and happy to help. So please follow the links, join Slack. Hope to see you there.
Thank you. Thank you very much for a great talk. A lot of insightful information with details, examples. That's really great. And I always love such talks because they always can be revisited, right? Just to check, okay, how to do this stuff, how to check that. So thank you very much, Anna, for being part of Java On and for your talk. So we do have a couple of questions. You touched them partially in your talk and in the last section, but still, let's try to address them. So first one is pretty technical one. And the question is, would Java unit test with test containers work properly within GitHub Actions on macOS IRM 64 environment?
Okay, I am trying to connect GitHub Actions to macOS.
I think when you use GitHub Actions, you select the base image where you will run it. And there is one of the base images is basically macOS image, because if you run GitHub Actions for Objective-C or Swift, you need macOS basically to build it. So I think this is the base of this question.
That's interesting. Usually for GitHub Actions, use cases that we see the most, they are actually Unix-based or self-hosted runners-based. So if image is, the main question is the image. Test containers is just a way how you start these images. If image is compatible with operation system, you will be able to start this container. If it is not compatible, we have Testcontainers Cloud, which is alternative runtime, Unix-based. Every container will be able to start there. For the GitHub Actions, if you go with standard way of how you run it, you don't use the self-hosted runners, then it usually works fine. If you use self-hosted runners with different OS or different types of machines, there can be issues, or you need to go with Docker and Docker. Again, we have Testcontainers Cloud for that. So if images are not compatible, test will be not able to run. If they are compatible, they will run properly.
Okay, thank you for the answer. Next question is a bit tricky, and you touched that in the last part when you said that test containers could be created by community. So the question is the following. Let's say our colleagues, one of our speakers, basically, they spoke about the experience of creating some cloud service, some messaging system, some database custom. So what would be the steps to create test container for this custom system and to provide it for the community?
Okay, let me go here. If you go to the GitHub page, we have here modules. There should be modules somewhere. Community module registry. This is the way how you can contribute your module to the community. Detailed instruction, how to do it, how to do the pull request. If you want to use your in-house technology for your testing, and you want to share it with other developers, but only within your organization, you can again build the module around this technology and just post it into your Artifactory or whatever you are using. It will be just a jar file that can be included into your Java project. So this is the instruction for community maintained modules.
Great. And I think I mentioned it yesterday when we spoke about Spring and open source projects. So Testcontainers is open source project. So guys, if you see something which you can contribute, I highly encourage all of you not to be shy, not to just say, it's not working. It's working. And you can be part of that. You can just go create your merge requests. Yeah, I do encourage all of you not to be just users, but you can be part of any open source technology. So yeah, please be the part. Okay, I think last question we can cover today because of time. Maybe you can give us some good practices, some advice on how to ensure that your containers have enough resources like CPU and memory to for tests to be executed fast.
It would depend on your either local Docker settings, I think, or on your remote Docker host settings. We have detailed documentation around this. I believe I need to double check. It's not the very often used feature. But yeah, I believe we have an API that will provide you information about how much resources container utilize. But again, if you know that your machine is not powerful enough and you experience issues with just local Docker, most likely it will be the same for just containers-based containers.
Okay, yeah, thanks a lot. So I think that's it. Thank you very much again for such a great talk. Thanks for being part of Java One, and hope to see you in future conferences. Thank you very much.
Thank you.
See you. Bye-bye.
Bye-bye.
Okay, so we are just one talk to go, but of course, all our talks are great, and we try to select speakers for you guys and ask them to join our conference, and we really appreciate them to accept our invitation. So let me invite here to the stage our speaker with whom we would close this conference, basically, and this is Jessica Kerr. Jessica, welcome to Java On 2024.
Thank you.
It was really nice having you here with us. So can you give us just small highlight what your talk would be about?
Yes, my talk is about how we deal with managing more and more complex software. As an individual software engineer, we're constantly asked to do more. So how do we do that? And one answer is we get the software to tell us what's happening so that we can understand it and fix it more efficiently.
Yeah, I can say that this is a very important topic. In 1 week, it's Black Friday, and I'm really waiting for my software to tell me if something will go wrong. So, guys, I want to remind you last time that you can put your questions in the chat where you're watching us. Well, I'm reminding Jessica, may I ask you to share your screen? And yeah, so ask your questions on YouTube chat, ask your questions on our community platform. I will collect all of them and ask them in the end of the talk. So yeah, we are nearly ready. Once Jessica will share your screen, we will show it on the stage. Yeah, guys, all your questions are appreciated. I do hope you receive a lot of useful information on our conference, and I do hope that you will be able to use it in your day-to-day work. So
It's not going to let me share my screen, is it? Entire screen. I have to restart Chrome.
Sure, no worries, no worries. We will wait for you. Okay, guys. So while we are waiting, that's okay. Like you can post in the chats your questions. Maybe you already use OpenTelemetry, so you can have your questions beforehand, and maybe that's why you joined us. So you can ask these questions already and put them in the chat. So first questions will be asked first, of course. So this is as we do. So yeah, just a reminder, all the chats I monitor, and yeah, I have quite a mess of the chats on my screen, but that's okay. No worries. This is my job here. Yeah, now we can see the screen. I will ask our operator to put it on the screen. Great.
Fabulous.
Okay, so yeah, good luck. Stage is yours.
All right. Great. Yes. I'm Jessica Kerr. Online, I'm Jessitron, and I work at honeycomb.io, which is an observability platform. And I'm here to talk about OpenTelemetry because observability is important right now. I'll talk about that for a few minutes, and then I'll do some live demo of like the difference between observability that used to be good enough and observability that's the best we can get right now. And then I'll talk about how OpenTelemetry makes that more feasible than it used to be. I've been a developer for like 25 years now. And back in 1999, when I didn't even have a laptop, I just had like this PC that sat under my desk and one of those big, deep CRT monitors. And back then, when I wrote code, I would test it to find out whether it worked. I'd like write a test harness to test my functions, and then I would delete that test harness before I committed my code to version control. And if it wasn't doing what I thought and I needed more information, I'd add some printf statements to the code, and then it would print stuff to my screen. And I still use printf statements, but I have alternatives as well now. And then I delete those printf statements too before I committed it. And that was it. That was like the extent of my responsibility as a junior developer. As my career progressed, I started being responsible for the software, like at least working with the other software, right? We get more services and more teams to work with. And now I'm not deleting my automated tests. I'm putting them into continuous integration so that my software continues to work as the system changes around it. And then I'm changing my printfs to log statements that I also can look at in integration tests. And that way, when something fails in integration tests, the other teams and I can have a fight, my logs versus your logs, over who did it wrong. And that was progress. At least the log statements might help when something goes wrong in production and maybe somebody brings me the logs and I look at them. But that's not enough for me anymore. It's not enough for me that my software be correct and that the integration tests pass. As a developer, what I want is to provide useful capabilities to people or sometimes to other software, which in turn provides useful capabilities to people. My software should make something possible that wasn't before, or more likely, make something easy that's otherwise hard. And that means my software needs to embody whatever complexity it's taking away from the people who are using it. So to provide more capabilities, my software needs to be more complex. And that typically means there needs to be more of it, more smaller units, more services, more teams working together on software that works together. In order to provide those capabilities, my software needs to be running in production, in collusion with all the other software that it collaborates with. And that's what I need to accomplish my goal. So now I care not just about whether my software meets requirements and passes tests, but whether in production it's really functioning. Are people using it? Is it fast enough? Is it as fast as it was last week? who is calling into it? Which different softwares are calling my APIs? And when mine isn't working, is it my code that's the problem, or is it some downstream? And which downstream? And how often does that go down? And when I do have an error in my code, is it important? How many people are affected? Which people are affected? I can, in theory, answer all these questions from logs, but it takes a lot of reasoning. Although I don't have access to the comment thing, or I would ask you whether you all have access to production logs or maybe APM dashboards or whatever, because I haven't usually had access to that in the past, but now I care deeply. And if I'm at a place that I can't get access to that, then maybe I can make friends with someone in operations or on the DevOps team or whoever does have access, because together we can work powerfully to improve the software and make life better for all of our customers. So I care about the system much more widely. And I'm always asked to support more and more software, or else add more and more features, and the complexity goes up, and I can't keep all this stuff in my head, besides which I'm maintaining software that I didn't write. My favorite software is legacy software because it's valuable, and that's what I'm looking for. But to do that is much harder than maintaining only stuff that I wrote and still remember. So I need it to tell me what's going on. I need observability. Observability is when we can tell what's happening in our software because it tells us, because we made it tell us. It means we don't have to reason from customer error reports. We don't have to wait for customer reports. And then we don't have to listen to their story, maybe look at production data in the database and reason through what might have happened and read the code and try to figure it out. It means it just tells us. We have a piece of data that says, hey, right here, something went wrong and this was the message, and probably not what to do about it, but at least where to look to figure out what to do about it. And that data is called telemetry. So these words come out of rocket science, because like when you build a rocket and you fire it off, you don't have like some cops in airplanes with radar detectors to tell you how fast it's going. You know how fast it's going because the rocket tells you, I'm going 500 miles per hour and the wind is out of the east. And next I'm going to fire this rocket off, or this jet, because I need to adjust my trajectory a little bit like this. It like phones home to say what it's doing and why. The data sent there is called telemetry, and it's sent because of instrumentation. Instrumentation is code that's just there to tell us what's going on. So every printf, every log statement, and every like metric counter that we add, these are instrumentation because they're there just to phone home and tell us as developers or operators of the software what's happening. It works locally, it works in integration test, and it works in production. But not all observability is created equal. And what I want is really good observability. One more concept that we're going to need that like doesn't actually work with the rockets, because the rockets aren't flocking like birds, but our software does kind of. Our software is like coordinating and talking to each other all the time. And in order to tell the story of what the heck our software is doing, we need it to pass a little extra information with every message of, hey, this is why I'm asking you to do that. That's called propagation. We'll come back to that later. The core concept here is that we need instrumentation code to emit telemetry so that we can have good observability and see what's happening. And what I get out of that is feeling like the running software is not like my enemy that gets me paged on weekends. It's on my team. I want to provide useful capabilities to customers, and I can't do that alone as a person. I can't be reliable enough for that. I need all the other people on my team and probably some other people if I can't deploy it myself. And I also need that software to be running in production. It's part of how I accomplish my mission. And I also need the tools that get it there, like my continuous integration, my deployment system, my IDE, my observability platform, my tests, and whatever else I use to learn what's going on in production. Because my code is learning from me because I change it, and I can learn from it. Better my observability, the better I can learn from it. So I like to think of the running code as part of my team, and that makes me happy. Speaking of code, let's go look at some. All right, I've got a service. Let's see, we'll start it up again with Maven Spring Boot run. And I can test. Okay, so I'm running it. All right. I can test it with curl because what it does here, clear curl again, is I call /phrase and it gives me a phrase. This one is not a bug, it's a feature. This one is test in prod. This one is you're muted. Great. Maybe I want to add another possible random phrase to it. So I go over to the code. Let's see, we're in phrase controller. Last time GitHub Copilot decided that I should add, I'm a software engineer, I don't have feelings. I changed that. No, we're going to do something different this time. GitHub Copilot. Oh yeah, we could just do hello world. That's kind of boring. I'm going to spell it wrong. That's funnier. Okay. So there I have inserted a random phrase. Now when, restart. I don't have hot reload going. So I can restart my service and then I can test it again. And I mean, it seems to be working, but did it pick up my random phrase? Why did it give me deploy does not equal release? Randomness is lumpy. That's a thing. I don't know. It could take me a while to actually get the new phrase that I added. So I need to add some observability. Okay, I could also make this more testable, but this is about production. I need to add some observability to know whether my change has really taken effect. So if I look at the code, there's some log statements in here. Oops, these are for later. There's some log statements in here where I'm printing out the size of the list and the choice. The choice is like a random index into that list. So I should be able to at least see a difference in the list size if my phrase is taking effect. Let's go see if we saw that. All right, last 4 log statements here are before request to get phrase, list size is 27, and then after request, okay. So currently the list size is 27. What was it before the last time I ran it? Aha, list size was 26. Okay, I have at least made a change. And so this log statement is some form of observability. But now let's run it in context. So if I do Docker compose up, then I'm running a little integration test of my, this one's called phrase picker, this phrase picker service in context with some other services. We see backend for front end, phrase picker, and memeinator. And then I can test this. Let's see, we'll need to be in Firefox. Here it is, localhost 8080. And I push go. We'll see if it works. It could be worse. That's my sister's puppy. And we can push go again. And we can get another meme. There we go. The screaming Clementine. And so now you see like what it's doing with the phrases. Oh, that one didn't work so well. Too bad I don't have a way to give feedback on the meme. There's a giant fork. All right. So this seems to be working. But if we go look at the logs, here's my phrase picker. That's good. And now here I'm running multiple services, but I'm doing exactly one thing. And therefore, the logs are largely intelligible. In fact, I can improve this by looking at them in, let's see, here's a local log viewer. This is Aspire Dashboard, which is a new release from Microsoft. I just found it yesterday. It's great. We can see here's our phrase picker before request. Oh, that's a list size of 26. What order are these in? I need you to query again, please. Still see a list size of 26. Oh, that's because Docker didn't build. It's fine. Please ignore that. But now I know that it's running a previous version of the phrase picker. It's not using the one that I just changed because I didn't say -- build and Docker compose up, which is because I don't have 15 minutes. So we can see the logs, but can I answer all those questions? If I want to see how long this request took, I have to like subtract these numbers. And also, who called into phrase picker? I think it was backend for front end, but then I'm cheating by knowing the app. However, I'm not only sending logs here, I'm also sending traces with OpenTelemetry. So if I click on this, I get the story of the request. So this is the distributed trace, and I'm going to go into some detail about that because it's like not obvious what a distributed trace is. But what it's doing is it's telling me that backend for front-end Java received a post. Let's see if I can make that bigger. There we go. Good. It received a post to create picture. And as a result, it did a get to phrase picker. Phrase picker received a get. So this distributed trace is telling the full story of what happened across all services, from backend to front end to phrase picker. Here it calls it into image picker, which is in Node, different language. Distributed tracing is very cross language. And then Meminator down here is the last service. And I can see how long things took. So this whole thing took 1.1 seconds. That's not bad. Let's see if I click on traces, maybe I'll get some other numbers. Oh yeah, here, this first one took 3.74 and this one put 2.43 seconds. But I can also see what took so long. So phrase picker here took 8.46 milliseconds. As the phrase picker team, I'm fine. But Meminator is taking 2.27 seconds. Some of that is a get, and then what is it getting? I can click in to each row here, which is called a span. A trace is made up of spans. And I can see, I know to look at the URL field, and I can see that it's retrieving clementine.png. Oh, no, that's the fork. So I was looking at the Clementine, the screaming Clementine one. You can get a lot of information out of a trace. And what's more, it's all tied together. And we'll show that in a minute when we deal with Meminator in production. But first, I want to pop back over here. And yeah, we did it with many services. And explain more what's the difference between logs and distributed traces, because I don't think this is obvious. So if you had like a tiny e-commerce app and it had this pathetic checkout service that receives a post to /checkout and that causes checking out, and then it calls cart and shipping and it does some database operations. Yeah, the cart is selecting and the shipping is inserting. No, actually the checking out has 3 steps: calling cart, calling shipping, and insert. Because the first difference between logs and spans, which are components of a distributed trace, is that linking between. These events are not disconnected. They're connected to each other using this propagation mechanism, because the checking out was caused by the post, and this select statement was caused by calling cart. Next difference, actually logs also tell you which service they're from. So that's pretty easy. But we do have multiple services participating. And then we have the span of time. So whereas a log always has a timestamp, a span has a timestamp and a duration. So you're covering some unit of work and describing some operation, not just a pinpoint in time of exactly one thing. Not just, hey, here's the list size and the choice, but I'm doing this whole thing about phrase picking, and it took this long. And then when there's an error, you can usually go right to it. You can find exactly the cause by looking at which one is deepest. And then while the span is happening, you can add all kinds of information to it, such as list size and phrase. And this is different from logs because logs, you're like, oh, I've got a list size, here you go. And it's not immediately correlated to like, what URL did I hit? So with this top span, the root span here, you have the URL at the beginning, but you don't have the status or the errorness till the end. And somewhere on there, we're sticking the CPU usage just so we can correlate that later with how long it took. You can add this information as you go so that it all gets in one place and you can do all kinds of analysis and correlations on it. So this one post is replacing 4 or 5 log statements, however many, at least a start and an end, and then however many in the middle you would have used to print these out. Oh, and then they all have the same trace ID. So there's one correlated story so that as you scale up, you can still see stuff. You can still tell it apart. Okay. And then there's all kinds of attributes on the spans, which we can check. Let's go look at ours. Here we go. So in get/phrase, I can see the span ID. Every row, every trace span gets a span ID of its own. They all share the same trace ID. Where's that? Trace ID is this 2F. And also, most of them have a parent ID. Parent. Where is it? Okay, so this one's parent is DB701 something, which tells me that, so that one has a different parent, but what's your span ID? Span ID is, where'd it go? There it is, DB701 something. All right, so this is the parent span of that one. And that's how this linking together works. Also, this one from back end to front end has a kind of client because it's calling out. And then this get/phrase has a server because it's receiving the request. This top one, which is called the root span because it represents the entire request from the customer's perspective, or as close as we can get to it. I don't see the network latency here, but this root span is the only one, it's a kind of server, it came in, that doesn't have a parent ID. And that's how we know it's the top and it represents the whole request. So that's how they're linked together. And then there's all this normal stuff that is added automatically, the get/phrase, or not the phrase, the get/phrase, yes, because that is the URL that it came in on. But this app.phrase and list.size and our choice, those were not created automatically. We saw those here. Those came from here. And I can bring that in from OpenTelemetry. So this is instrumentation, manual instrumentation that I wrote because this information is important and it replaces these log statements really. And all of this is, it's technically possible without OpenTelemetry, but it's much easier because I'm using OpenTelemetry. All of that distributed trace was very little work because a lot of people have worked really hard to make this easy in the last 5 years or so. So OpenTelemetry recognizes that in today's complex software, distributed tracing is really useful. Also, logs and metrics can use some standards, and it has those as well. But especially distributed tracing is really hard without OpenTelemetry. OpenTelemetry is an open source project. Really, it's kind of an umbrella over many projects. So there's protocol specifications, there's naming conventions, an API to write that instrumentation that I just showed. And this is across languages and it's across frameworks. OpenTelemetry is also part of the Cloud Native Compute Foundation, which is like a very official and there's governance committees, multiple ones, and there's ambassador programs, and there's change request processes and working groups in so many meetings. Okay. A lot of people are spending a lot of time making these standards so that we can build on top of them. It's the second biggest project in the CNCF by a lot of measures. I think it might be first by number of contributors by now. But the first biggest project that the CNCF is most known for is Kubernetes. So OpenTelemetry is very serious business in open source. This is not somebody's hobby project. I mean, it's many, many, many people's hobby project, but then they're coordinating and doing a lot of work. There's foundations and yeah, there's a lot of stuff. And all of this so that we can more easily write instrumentation to get telemetry that gives us clues about what's happening. In particular, OpenTelemetry provides a standard for the format of the data itself, ensuring compatibility on both ends. That is called OTLP, which stands for OpenTelemetry Protocol. I don't know where the L comes from. And also the instrumentation code that emits data in that format. Because I don't have an OTLP receiver in my brain, the data doesn't actually flow straight into my head and give me clues. So it's a little more complicated than this. Once you have that telemetry data, you have to put it somewhere. You have to put it in a database. And then to get the clues, you have to query that database. So this whole part of storing the OTLP data and then querying it and displaying it to users and letting us ask questions, letting me ask how long does it take, letting me ask which errors are important. That is the responsibility of an OpenTelemetry backend, which is not actually written in, not part of the OpenTelemetry project. It's compatible with OpenTelemetry. The good part is there's lots of choice here, maybe too much. So you can use an open source tool like that Aspire dashboard, which is really just for local, or the Jaeger is a CNCF distributed tracing tool that we'll see later. There's open source tools for logs and metrics, or you can use a vendor, and all of the observability vendors accept OTLP. So Datadog, New Relic, Splunk, Sentry, Honeycomb, of course, which is the best. That's why I work there, see. But we all accept OTLP. And one of the beauties of that is that as a vendor, we have to continually work for your business. We can't just say, oh, well, our agent is embedded in your code, so you must stay with us and pay us millions of dollars every month. So having standards and flexibility is really good for competition in the industry. And I think that's really pushed our standards of observability even higher. So that's one reason that OTLP is really great. And everyone should move to OpenTelemetry because it gives you this flexibility. You can start with a SaaS platform and then move to open source if you don't like it. Take your pick. The way it does this is by providing code in every language that implements they call it the OpenTelemetry SDK, which is an implementation of the OpenTelemetry API. And it lets you do things like start spans, add attributes to the span, and end the span. But mostly you don't want to do this, actually. Oh, yeah. And then there's like keeping track of that span in global space, which is different in every language, and every execution flow. So different, like the Akka will do this differently from WebFlux, but all of them use thread locals at some point in Java, but it's different in every language, how we make that span available globally for the set attributes. You don't want to have to worry about that. The OpenTelemetry libraries worry about that. And even more, they do the start and end span for you. Because if your application, say, calls out to a database, then maybe it's an HTTP server, so you're using frameworks and a client library for the database, OpenTelemetry has projects that know about each of these. And then they do bytecode injection to add instrumentation around those libraries so that when you make a database call, it creates a span with kind internal and the db.query populated with your query string, but not the parameters, because those might contain private information. But as long as you parameterize your query, you get select from table where question mark, question mark. It's really useful to have that information. And it all goes onto the spans. And then that gives you the sends wherever. Oh, and it does the propagation for you. So this is giving you the structure of the distributed trace, because OpenTelemetry libraries plug into your HTTP client library, among others, and they add a header, an HTTP header called trace parent, that includes the trace context, which is the trace ID and the current span ID, to say, hey, this is why I'm asking you to do this. Link your events up. So that server span, it's a client span from, say, backend for front end, gets this header injected onto it. You don't have to write any code for that. And then, and the web server library, so Play or WebFlux or MVC, whatever, the instrumentation that injects code into that library will pull that header off and start a span that is a client span and has the same trace ID, and the incoming span ID is its parent. And this is how we link it all up. Propagation is kind of magic. And there's standards for gRPC, metadata, and for Kafka and various other communication mechanisms. So only if you have something custom do you have to worry about passing that metadata along yourself. So that all comes from OpenTelemetry. And this is how you get that working in your software. So I can show you like my Docker file. Here's a Docker file. The easiest way to use OpenTelemetry in Java, and the recommended way, is like from the outside to inject this Java agent, which like digs around in your code and injects whatever it can inject as part of the Java command line. And that Java agent is downloaded from GitHub OpenTelemetry releases. Here's version 2.90. And then it's configured in environment variables. So I just have some simple ones here. Here's where you should send the data. This service is called Phrase Picker Java. And also send me the logs in OTLP log format. And it'll like attach trace IDs to logs so that your logs can be linked up to the trace later. It's really cool. Okay, I think I might have done a tiny bit of log configuration to make that work, but mostly just turning on Log4j. Right, so you can also configure a lot of other things like use this instrumentation, don't use this instrumentation. Like the Redis one can be noisy. Some people turn that off. This function that I wrote, make a span around it, all kinds of interesting things you can do just in the environment variables, especially in Java. That's super powerful. Okay, so that's how you get OpenTelemetry to work. It's just this. And that gives you like the whole outline of the trace. And then we've seen what was in those spans. And then you can do that little bit of custom code to add the fields that are important to you. Now, in this case, whatever the choice, the list size, not super interesting. But in real life, you want customer ID here or user ID, not their email address, because that's PII, but their ID that's only meaningful inside your system. So you want to know who these errors are happening to. You want the stack trace in here if there's an error. You want all kinds of things, especially what's valuable to your business. If you're multi-tenant, this is hugely important because every tenant is having their own experience and you want that tenant ID on your trace. So a little bit of code goes a long way there. And that's called custom instrumentation, where you just call set attribute, like I did in the phrase picker, to put your custom stuff on there. And so this little line of code really decorates and adds value to the wider outline. Oh, and here's the dependency. So like to add the Java agent, I don't have to even like change my POM or my Gradle file at all. Well, unless you're telling Gradle to start it up. Only include the OpenTelemetry API in your application code. And then if the Java agent doesn't get attached at runtime, then these are all no ops. all those set attributes and stuff. They're all just no ops. Oh, and this is the bomb that makes the version number be populated when I put this in my POM. So dependencies, they're so hard. Right, but only bring the API into your software. You don't even have to bring the implementation code. Okay, and the beauty of distributed traces, I promise, is they scale up to production. So please go here. You can scan the little code or the barcode and do this on your phone if you want, or you can go to justitron.com/meme and it will redirect you to a longer URL. This is fine. And run the Memenator and let's see what happens in production. And we'll see what's going on with it. Okay, let's see. Here's a Memenator. Go. Let's get the network tab open and clear it so I can see what's going on. Go. Aha. Okay, it's working. Y'all haven't broken it yet. This is running in my own toy EKS cluster. No guarantees. I do not have any SLAs for Memenator. But see what you can get. Oh, there's an error. Okay, I got an error. That's fine. There's the giant fork. All right, now let's see what's happening. If I go, the shortcut is justitron.com/otel/Jaeger. You can go here too, because this is open, because this data is very not sensitive. And you might break it. FYI, this is like in-memory Jaeger instance, and when it gets full, it falls over, and Kubernetes restarts it. Okay, so when you get to Jaeger, you want to click on search and then choose the phrase picker and do find traces. Yeah. Some people have been clicking it. Good. I didn't make all of those. And then we can click on one of these. Oh, in here, I think that the higher ones are slower. There's duration. Oh, there's a failed one. We can look at where it failed. Oh, yep. The lowest error is in Memenator Java. And it says this get failed. And this one always fails because it's got spaces in the URL, and that one doesn't actually work. So I'm not seeing, this doesn't give me a good error message, but it does tell me at least what URL I failed to retrieve. And then I can go copy this and throw it up here. Oh, wait, I don't want to lose that window. Throw it up here. Oh, it actually works from the URL bar. So yeah. What's your problem, Memenator? Where was I? Okay, I was at this trace. But you can look at what took so long. Now you may notice that in this version, in the production version, Memenator Java has an extra span because it's taking forever. It's taking 1.29 seconds here. What all is it doing? 314 milliseconds are a get. One of the other things it's doing is running this convert command. And I got that by adding Memenator controller, this single annotation says create a span around this function. Now that's a Spring thing, and required an extra import, but it gave me a span because this is an important unit of work in my operation. I'm actually calling out to the shell, so it should definitely have a span. And then I think I add an attribute to it. Oh, and the standard out, I added some more attributes down here. And then I ended the span. It's very important to end your span. You don't get telemetry for creating spans. You get it for ending the span. That's key if you're going to do this. Wait, I should actually, that's wrong. I don't have to end that span because Spring is going to do it for me. There's a different way to create spans that I must have been doing earlier that you have to end it, but Spring is going to do it for me with this annotation. And well, the OpenTelemetry code that integrates. Okay, so let's see what else we can learn about what's happening in production right now. We saw some traces. Let's see. Can I search again? Find more traces. Yeah, there's a few more. I can't look at logs in Jaeger, but I can in Honeycomb because I'm also sending this data to Honeycomb. So let's look at logs for the last 10 minutes. And I can see, yeah, there's a bunch of stuff happening in Meerson web and image picker and backend, but it's really hard to follow like any one thing that's happening. Let's look over here. Show me some of the new ones, view events. There's just a few. It's really hard to find out what's going on from the logs, whereas a trace makes a clear picture. So this is why I think traces scale a lot better than logs. There's also different ways to like cut down your data volume, because I can save whole traces and keep whole stories instead of random logs that I might never get the whole story if I drop random logs. But dropping carefully chosen traces is quite, ooh, look, did we get an error right here? Check this out. And here's here's a debug log right in with my span. And it has a bunch of stuff on it. What does it say? I don't know. I'm not sure. I don't think this is actually an error. I think it's just pink because pink is pretty. But you can integrate the logs directly with the spans, and that's handy. I like that. Right. And then you can say, okay, oh, check this out. Check this out. This trace actually started in the front end. And so my post from Meerson web, which is what we're seeing over here, took 7 seconds. Whoa, that's really long. But my backend only took 2.3 seconds. All this rest is network latency. So this is a pretty good picture of customer experience and how we can optimize even Meerson all we want. But really, maybe we should be like running in a CDN or someplace other than my toy EKS cluster. That doesn't get its requests fast enough. And we can also ask, like, is this normal? Is it normal for us to take 2.3 seconds? And okay, I can't do this in Jaeger either, but I can here. Because if I have all this rich data like phrase and image URL is one that shows up in the Meerson, then I can correlate that with slowness. So like this graph is going to tell me what's slow for create picture calls. Y'all aren't hitting it very much. I'm going to have to go hit it some more. Last 10 minutes. Oh, there we go. Okay. And I can say like what happened with this 8-second one. I bet it was network latency. Yeah, view trace. No, this one, no, that one's was just 3 seconds. I clicked on the wrong dot. This was Meerson. Anyway, I can also say like which images were slowest. Look by image URL. And a real heat map was fast, probably because it failed. Oh, I'd have to get, look at the P90 or the max duration. Being able to query over these makes it more fun. Okay, so the slowest one was Bigfoot in this case. We only got one of those. And there's some correlation. Anyway, tracing, amazing. You can do it in multiple tools and you get the whole story of a production request, and this scales up in a way that logs, where's that logs picture? Oh, I've clicked into something. Here's some logs. The logs really don't. It helps me get oriented in what my software is doing where. Sorry, Jaeger. And it really helps me understand what's happening in my production software in context of the other software. And this used to be incredibly hard and take an amazing amount of manual work through your system. But with OpenTelemetry, it's completely feasible. Yep, there's the POM bit for the annotation to create a custom span. Overall, thinking about observability means asking my software to do a better job at telling me what it's doing. Not settling for what works locally, but expecting to test in production And even if I'm not allowed to run tests in production, my customers are constantly. I would like to look at the results and have them be meaningful. So I have instrumentation, I have telemetry, and even if that's just logs, that's fine. I can use a log aggregator to read them. Or if I have APM and it's just counters, then I can't know, like, okay, which customer was it slow for? But I can at least know whether it's slower than last week. That's something. And then with distributed tracing, I can get all that detailed information and the troubleshooting. And if you combine all three of them win. Recommend. In any case, I want to think about my software as part of the team and make it really productive. OpenTelemetry is an industry standard. It's super solid. Everyone's moving to it at some rate or another, if nothing else, because their observability is too high and they want choices. But Java has the best OpenTelemetry support of any language. So as a Java dev, you're uniquely positioned to work with this. Oh, yeah, you can, like, I think I Googled OpenTelemetry Java support. They have a whole list. These are the libraries that we have instrumentation provided for. And I'm still in the A's. Okay, I got to the E's. It's a long list. You can also go to the opentelemetry.io/registry and find there you can look for any language and any library. You can look at the repositories directory. OpenTelemetry Java is the base API and SDK. And then Contrib has a lot more instrumentation in it. And also like more exporters and stuff like that. You can do this locally. The Aspire dashboard in particular is pretty easy to run locally. It's a Docker container. And so you can run with the Java agent attached to the services that you can run locally and see it. And then it's also really useful for reducing build times by like finding the slow tests. There's lots of things you can do with it in addition to production. If you can't send your production data somewhere, that can be hard. This is how I have to change Maven to get it to start up correctly for Spring Boot. And then if you really want to understand it, learning OpenTelemetry is for people using OpenTelemetry. It has all the different concepts in the API by my coworker, Austin Parker. Overall, observability is an important part of a healthy production software system. If you don't have it, every incident is worse because it gets you to the root of an error quickly, and also you can measure the impact of an error. Very useful. When you're serious about OpenTelemetry in production, you want more than just slap the Java agent on your software locally. You want all apps that are part of the request response chain to participate so you can get the whole story. You also don't want all of those apps configured separately to send it to a particular backend. You want to send it into your telemetry pipeline, which usually means an OpenTelemetry collector. So this is yet another piece of the OpenTelemetry project. It's really useful. You can receive data in legacy formats for Jaeger and Zippin if you had tracing already. You can run this collector as an agent to collect your logs from files. And then you can process them and convert them into OTLP, lots of different stuff. You can get Prometheus metrics. You can configure it in YAML, not surprising. Does a bunch of things. You can format your data. If you're serious about this, like being the observability person at work, then you want this book, Observability Engineering, which talks about what you need in a telemetry backend and how this stuff really works. By Charity Major, she's my CTO, and Liz and George. It's a great book, and it has a fox. Overall, I think observability is an important part of what lets us as an industry progress from writing code that works on my box to writing code that actively works in production and increasingly serves users. And it makes it part of the team, and that feels good. It makes me more powerful, makes me able to have a better impact on the world. Okay, we can do questions, but also if you ever want to chat about observability or OpenTelemetry or whatever, I have office hours at honeycomb.io/office-hours. My personal blog is at justitron.com.
Wow. Wow. Thank you very much for such a wonderful presentation. I am like working on observability in our system for last a couple of years. Like second time in observability like back in it, and do hope that more people who are watching us would be in it and would bring this to their project. So thank you very much again for this super presentation. I don't know. I don't have words to be honest.
Thanks. I'd love to hear more about what you do.
Yeah, we can discuss it separately.
I'll take that offline.
Okay, so a couple questions from the guys. So first question is from Andrei. It's about third-party services that suppress telemetry headers and that overall trace is interrupted in this case. So maybe you have any recipes or how this issue can be addressed.
Okay, so we're talking about propagation here, and propagation comes in on an HTTP header. For instance, the Memenator in production, my front end actually, that like the React app is using OpenTelemetry instrumentation to add the trace parent header. When that comes into the back end, it's still got the header because I control everything in between. Well, close enough. Amazon doesn't strip it off. So the propagation continues to work. If you were going through a gateway that was stripped that header and took it away, you wouldn't be able to connect your backend to your front end, or this might be in the middle of two backend services, whatever, and get the whole story in one trace automatically. You could do some manual propagation trick to get around that and add the trace context, the trace ID and span ID to your message. And some people do it that way. There are some, Kafka is okay, but there are some queuing software like SQS. I think you have to add it to the message because it won't pass it along for you. And that's manual propagation, and it can be configured, kind of a pain. Another way you can do that is, have two traces. You can do the usual thing that people do with logs and pass a request ID, which may or may not be the same as the originating trace ID, through and coordinate it that way. You can also make a span link. But honestly, if it's really important that they be in the same trace, I would do manual propagation if I can't configure that third-party service. But the other thing you can do is when you call that third-party service, if this is a synchronous call, at least you're going to see the duration of that. Because sometimes it's a downstream dependency and your stuff doesn't get called back. And then, well, you just see how long it took. And that's invisible. But if you want more, you can come to office hours. honeycomb.io/office-hours. And it's my favorite part of my job, honestly, is answering people's questions about getting tracing and OpenTelemetry working.
Great. Thanks for the answer. Another question was about Spring Web Flux, and you touched it partially in your talk. So question was rephrased in the middle. So the end question is the following. How does exactly the tracing work for reactive apps, and where is the context store when request processing switches between multiple threads?
That's a good question. Actually, Spring Web Flux, when you're using the reactive calls, it's a little confusing because I have had to save the span in a local variable and pass it down in. So it does get tricky. I don't know exactly what it's doing, and I've wanted to figure it out. You can also email me. I'm justitron@honeycomb.io and give me an excuse to actually spend the time to dig into the details of that. Because I haven't dug that deeply into what OpenTelemetry is doing. It's doing something interesting. But the asynchronous reactive style doesn't perfectly work the way I want it to intuitively in OpenTelemetry, because I can make logs that show up on a span that it's already closed, which is actually a pretty useful thing to do. In Honeycomb, at least, I can see the span, and then that span has finished because it's doing something asynchronous. But here's a log over here that was still in that span context. It's pretty interesting and fun to explore. But sorry, I don't have a super clean answer for the functional reactive programming.
Yeah, anyway, thanks for that. I want just to add about that. So that's great that we have Spring with its magic. So sometimes we don't know exactly how it works. Always we can deep dive there, but yeah, good that magic somehow is working. So another question is, I think it's some pain point for a lot of people who use observability. I will just read this comment because I think it's really important for like a lot of people how to deal with it. I mean, so Tatiana used Tatiana's personal pain point in observability solution is that she used how to choose. It's a problem for her how to choose right strategy and balance of the amount of stored traces logs metrics and memory space that it all is, right? So we do want to have observability. We want to have ability to dive through that. But next day, our SRE engineers come to us and say, hey, you know, we spend too much money on this storage, so we need to clean it up. So maybe you can give us some advice on how to deal with that.
Great. Yes. I didn't talk about cost and I didn't talk about sampling. So I'm happy for the question. When you're storing logs and you have to store all of them, you kind of look for the cheapest storage you can get. But there's a trade-off between the cost of the storage at that volume and how searchable it is and how queryable. With traces, the best strategy, like the most advanced strategy, is dynamic tail sampling, where you add a step, a dynamic tail sampler, ours is called refinery, in your telemetry pipeline that accumulates the whole trace and then makes a decision. Do we keep this one or throw it away? So you've got the whole story. You're either going to keep the whole trace or not, or none of it. And if it's an error, keep it. If it's really slow, keep it. That's interesting. And then look at the URL. If it's a health check, maybe keep 1 in 1,000 and throw the rest away. If it's a checkout, maybe keep everyone or maybe keep 1 in 10, because that's like a critical part of getting money for your business. And the 1 in 10 that you keep, make them be distributed across regions or tenants, so that you get a good even sample. And then when you do that, your sampler will record the sample rate. Like if I'm throwing away 9 out of 10 of these, the one I keep is going to get a sample rate of 10 because it represents 10 requests. And then your aggregators that are deriving your application metrics from the traces can take that into account and say, okay, I've got all these traces, these errored ones count as 1, and these ones count as 10, and these ones count as 1,000, and use that to get the numbers right. I mean, it's always approximate, but metrics are generally approximate anyway. And you can make sure you get a good distribution when you're doing your dynamic sampling really cleverly. And with that, you can also set a target of, I only want to send 1 million events per month. That's too low. 1 million events per week. So sample it to whatever rate is necessary to achieve that target. So that's how you can get predictable costs, and you can tune it to only spend what you want. But then you still have the full story of the errors, and you have enough successful ones to compare them to. I think of it like with metrics, and I'm in this strategy, I'm not even keeping separate time series because time series are fine for infrastructure metrics, but for application metrics, they're never granular enough. They never tell you who it failed for or what the exact exception was. Whereas if you derive them from your traces or your logs, works with logs too. You have that granular data. So skip scoring the time series, that's a cost saver. And then sampling gives you still the shape of the forest that you would otherwise get with metrics, but you could also drill down and look at an individual tree, and you get all the sick trees and enough healthy trees for you to compare them and see what's wrong. Whereas if you only keep logs and you don't have traces, well, if you have request IDs on your logs, then you're okay. But unstructured logs are more like a pile of leaves.
Great. Yeah, thank you very much. So we're running out of time. So I want to thank you one more time for your amazing talk, and thanks for being part of Java On.
Thanks for the really detailed advanced questions.
Thank you. I hope to see you on our future conferences. Thank you. Bye.
Bye.
Okay, guys. Okay, so yeah, we are coming to the end of our conference, and I just have a couple thoughts to share with you. I know it could be late, quite late in your location. We just wanted to give more opportunity for people in different parts of the world to join us. So thank you very much for being with us through all this time, 3 days. So wow, quite a lot. I hope we covered quite a lot of topics, and I do hope you enjoy the conference. So yeah, let me just go through our slides one more time. So our team. This conference is brought to you by these amazing communities. You can join them on We Are Community platform. So it's Jacob community, Minik community, Java Lineup, and ICE. So please join these communities. Also, we have sponsors. This is We Are Community platform. This is EPAM, of course, JetBrains, and Comday community. Also, I want to show you these logos of our partner communities who helped us a lot in spreading the word about our conference and helping in preparation. Thank you, everyone. These are communities all around the world. So thank you very much for being part of Java On. It's really a pleasure to work with all of you guys and have you all on board. So yeah, I want to remind you about our socials. So we do have Instagram, and this is QR code where you can join us. This is our YouTube channel. So you also don't forget to click subscribe button, so not to miss our future conferences and our webinars. It's happening here, and all recordings would be on this YouTube channel. Right after the conference, we will start preparing them, and later we'll publish them. And yeah, don't forget about our activities. So they will be available till the end of this week, and next week we'll send an email about the winners, and also we'll send you an email about leaving feedback on the conference. And among those who leave us feedback, we will also make a raffle for IntelliJ licenses. And last but not least, Java On team. These people bring you the conference. So I hope you give a round of not virtual but real applauses to all of them. So these are people who working through this year for bringing this conference to you. Thanks to all of them. Really great job. And guys, you are on the backstage. I have to speak for all of you here, but thank to all of you for work through this year and for bringing this conference to all of us. Yeah, and that's basically it. Thanks for being on Java On. That was a pleasure to deliver you this conference, and hope see you soon. And saying that, I have last thing to mention, that finally Java On is off.
Thank you.